The camera does not find the ship at first. It finds particles, moving slowly through black water, each one bright for a moment, and then gone, as if the ocean is giving the machine only fragments of itself. The depth number in the corner of the screen has already passed anything a diver could survive. The cable above the vehicle is no longer aligned to a boat so much as a narrow permission to exist here. Then, the beam touches metal. Not shining metal, not the clean edge of a vessel as it once moved under its own power, but a torn plate half buried in sediment, its surface softened by rust, bacteria, and time. The object is human, but the place around it is not. A squat lobster moves over a rivet that was never made for claws. A fish hangs motionless beside a collapsed railing, using a warship or a liner or a freighter the way another fish might use a ledge of basalt. A brittle star bends its arms through silt inside a room where people once stood upright and read instruments. Nothing in the frame is dramatic in the ordinary sense. There is no storm now, no shouted order, no flare on the horizon. There is only the steady pressure of water and the slow work of animals that do not know the story of the wreck beneath them. This is where shipwrecks become something different from history. Near the surface, a wreck can still feel close to us. It can be touched by divers, photographed by tourists, covered in sunlight, and entered by animals that belong to coastal reefs and shelves. But beyond a certain depth, the wreck leaves the human world almost completely. It passes through the last usable light, through layers of migrating fish and drifting plankton, through water too cold and too heavy for ordinary access, until it arrives on a seafloor where the ship is no longer a vessel. It is a sudden piece of hard landscape in a place that may have been mud for thousands of years. A ship is built for buoyancy, cargo, weather, propulsion, and human movement. The deep sea asks none of those things from it. It asks what its steel will do under pressure, what its wood will do in cold water, what chemicals will leak from its paint and fuel, what bacteria can use its iron, what larvae will settle on its edges, and what animals will arrive once the structure begins to hold life. The sinking is the human ending. The descent is the ocean's beginning. At 300 meters, a diver already becomes a specialist, wrapped in procedures and gas mixtures and danger. At 1,000 meters, sunlight no longer reaches in any useful way. At 4,000 meters, a ship sits in the midnight world, under hundreds of atmospheres of pressure, where the temperature may hover close to freezing, and the food supply comes mostly from what falls out of the surface ocean. At 6,000 meters and below, the wreck enters the abyssal and hadal scale, where even many machines are near the edge of what they were designed to withstand. The ship has gone to a depth where the surface world can only visit through thick glass, titanium, fiber optic cable, sonar, and patience. If the hidden ocean is what brings you here, subscribing keeps the next descent close. The phrase "beyond human reach" does not mean that no person has ever sent a machine there, or that no crewed submersible has entered those depths. It means that the wreck has crossed the practical boundary of the body. A human hand cannot simply go down and brush away the sediment. A human eye cannot look through a mask and follow the curve of the hull. Every observation must be translated through technology, through acoustic returns, camera beams, navigation logs, pressure housings, manipulator arms, and screens in darkened control rooms. The wreck can be seen, but it cannot be approached in the ordinary human way. That distance changes the nature of knowledge. In shallow water, archaeologists can measure by touch, place scale bars by hand, and spend long hours moving slowly over a site. In the deep ocean, time is expensive. Ship time is limited. Battery life is limited. Visibility changes with a touch of sediment. A thruster can erase a delicate layer of silt that may have been accumulating since the day the ship struck bottom. Even a careful vehicle is an intrusion. The deep sea does not offer a wreck to us as a museum exhibit. It allows a narrow beam of light to pass over it, and from that passing light, we try to reconstruct what happened. The first thing that happens to a sinking ship is not mystery. It is physics. The hull loses the balance that kept it on the surface. Compartments flood. Air escapes in bursts. Loose objects rise, while the heavier structure falls. If the ship breaks apart near the surface, the debris field begins before the main body reaches the bottom. If it remains together longer, it may descend almost like a dark building falling through water, rotating, shedding pieces, collapsing under its own damage, and entering pressure that increases by about 1 atmosphere every 10 meters. Pressure does not crush everything equally. A sealed pocket of air can implode. A hollow container can fail. Glass, ceramic, steel, copper, and bone all respond differently. The open spaces of a wreck fill with water, and once pressure is equalized inside and outside, a massive structure may remain recognizable at depths where a human lung would be useless. This is one reason deep wrecks can appear strangely intact. They are not protected by kindness. They are protected by a balance of forces, by cold, by darkness, by distance, and by the fact that some forms of destruction happen faster in shallow, oxygen-rich, wave-touched water than in the slow chemistry of the deep. But the deep sea is not a place where wrecks are simply frozen. Even in darkness, there is movement. Bottom currents pass over the hull. Sediment accumulates against one side and is removed from another. Iron oxidizes. Wood is consumed if the right organisms and oxygen are present. Paint peels. Aluminum powders. Brass holds a different color. Microbes form communities on metal and in the surrounding seabed. Larger animals arrive when there is shelter, surface, food, or the presence of other animals. A wreck can preserve history and still be actively disappearing. There is a temptation to imagine the deep ocean as empty because many camera frames seem empty. A vehicle descends for hours and sees only water, particles, and darkness. Then the seafloor appears as a plain of pale sediment, crossed by the tracks of animals that have already moved away. But emptiness is not the right word. The deep sea is sparse in any single frame and immense across volume. A wreck placed inside it becomes an event. It introduces height where there was flatness, shadow where there was open mud, metal where there was sediment, and crevices where an animal can hide from a current. A shipwreck is not a reef in the romantic sense at first. It is a disturbance. It arrives violently, often with heat, fuel, debris, and the remains of people or cargo. It may scrape the seafloor, bury organisms, and release chemicals. But after that first violence, the structure begins to be colonized. Bacteria form films. Larvae carried by currents settle on exposed surfaces. Hydroids, anemones, sponges, corals, barnacles, crinoids, and tube-building animals may attach depending on the depth, region, oxygen, current, and material. Mobile animals follow the structure. Fish use it for cover. Crabs and shrimp patrol it. Octopuses investigate cavities. Hagfish may enter when carrion is present. Over years and decades, the wreck becomes a small island of altered habitat. Scientists study these sites not only to learn about ships, but to understand ecological processes: succession, connectivity, disturbance, corrosion, food flow, microbial diversity, and the way life responds when a hard object appears in a soft-bottom world. The human story brings us to the wreck. The ecological story explains why the wreck does not remain only human. For a deep-sea channel, this matters because the ship is not the only subject. The ship is a frame that allows us to see the water around it. When an ROV passes over a bow at 4,000 meters, the image includes engineering, tragedy, archaeology, microbial metabolism, scavenging, and the slow rain of material from the surface. It includes the fact that a lanternfish may have fed near the surface the night before, and that particles from that feeding may eventually fall past the wreck as marine snow. It includes the fact that a grenadier in the light beam may be living by rules older than the ship, shaped by cold, pressure, hunger, and the need to conserve energy. The wreck changes the seafloor, but the seafloor also changes the wreck. On a continental slope, currents may be stronger, sediments may move, and canyon systems can funnel organic material from shallow water into deeper basins. On an abyssal plain, the wreck may sit in a vast field of fine sediment where tracks remain visible for a long time. Near seeps or vents, the chemistry of the bottom may already support unusual communities, and the wreck becomes one more hard surface in a chemically complex place. In trenches, where depths pass 6,000 meters, the wreck enters a hadal environment where pressure is extreme even by deep ocean standards, and where the animals around it are adapted to a world that most ocean instruments were not originally built to enter. Every lost ship has two maps. One is the map of the surface, the route, the storm, the battle, the iceberg, the ice field, the navigation error, the last radio signal. The other is the map of the descent and the resting place. That second map is harder to draw. It belongs to currents, slopes, impact scars, debris trails, sediment fans, and the scatter of objects that fell at different speeds through the water. A bell may land far from a boiler, a boot may vanish, a gun turret may remain upright, a porcelain plate may survive what steel did not. The sea separates a ship into evidence. The deeper the wreck lies, the more that evidence depends on machines. Sonar may see the shape before cameras do. A side-scan image may show a long shadow on the bottom. A multi-beam survey may reveal a mound or a straight line where geology would not make one. Magnetometers may detect metal beneath sediment. Then an ROV or submersible descends, and the acoustic shape becomes a place. In the control room, people watch monitors as if they are leaning over the edge of another planet. A number changes in the corner. The altitude above bottom narrows. Marine snow crosses the lights. Then, if the search has worked, something made by human hands appears in a world where no human hand can reach it. The most famous deep wreck is not the deepest, and that matters. Arms Titanic rests about 3,800 meters below the North Atlantic, far below sunlight and far beyond ordinary diving, but still shallower than the deepest war wrecks off the Philippines. Its fame comes from the surface story, the maiden voyage, the iceberg, the lifeboats, the scale of loss, and the cultural weight that gathered around it afterward. Its scientific importance comes from something quieter. It became one of the places where people learned how a modern steel ship behaves as a long-term object in the deep sea. When the wreck was found, it was not sitting as one preserved ship. The bow and stern were separated, with a debris field between them, and the two sections told different stories. The bow still carried the recognizable outline that people expected. The stern was more chaotic, torn and opened by the forces of the sinking and impact. The difference matters because deep wrecks do not simply sink, they are transformed on the way down. The surface disaster may last hours. The descent may last minutes. The impact may last seconds. The afterlife may last centuries, but it begins with damage already written into the structure. In close footage, Titanic does not look cleanly historical. It looks biological. Rust hangs from the steel in fragile formations, sometimes called rusticles, and these are not just decorative signs of decay. They are associated with microbial communities involved in the breakdown of iron. The name makes them sound like frozen objects, but they are part of a living chemical process, a slow conversion of ship into mineral, waste, and microbial habitat. A railing becomes a place where bacteria feed. A hull plate becomes a boundary between archaeology and metabolism. The ship is being remembered by people and consumed by life at the same time. The animals around Titanic are not there because the ship was famous. They are there because the ship is structure. Deep sea fish pass through the light. Anemones and other attached animals use surfaces where they can hold position above the sediment. Crabs and small mobile scavengers move across places that once had names on deck plans. The wreck gives them elevation, shadow, and hard edges in a muddy environment. To the animals, the ship is not a tragedy. It is shelter, current break, food web, microbial bloom, and one more surface in a dark world of surfaces. There is something uncomfortable about that, but it is also clarifying. A wreck can be a grave and a habitat without either truth canceling the other. The ocean does not pause its processes because human beings attach meaning to a site. Steel corrodes. Microbes grow. Sediment drifts. Animals settle. The ethical question is not whether the wreck should change. It will change. The question is how much human interference should be added to a place that is already being altered by time, chemistry, and life. The cold does not stop decay. It slows many processes, changes which organisms can operate, and removes the wave energy that tears apart shallow wrecks. But it does not make a deep wreck immortal. In shallow water, storms can break a hull, surge can grind metal against rock, and sunlight fuels dense growth. In the deep ocean, the attack is often quieter. Corrosion proceeds under low temperatures and low oxygen. Microbes exploit materials. Currents move sediment one grain at a time. What looks stable in one expedition may be measurably different in another, especially when researchers compare images, corrosion samples, or high-resolution maps across years. Titanic also shows how deep wrecks become laboratories for technology. Early images were grainy, limited, and astonishing because they proved the site could be seen at all. Later expeditions produced sharper video, mosaics, photogrammetry, and three-dimensional documentation. Cameras improved. Lighting improved. Navigation improved. The ability to return to the same feature and compare it through time improved. A deep wreck is not only a subject for archaeology, it is a test of how well human instruments can work in darkness, pressure, and cold without touching more than they need to touch. There is a common misunderstanding that the deeper something is, the more preserved it must be. Titanic complicates that. It lies in deep cold water, but its iron is actively deteriorating. A wooden ship in a different deep environment may last longer if wood-boring organisms are absent. A steel warship may remain upright, but lose thin structures. A cargo of ceramics may outlast the hull that carried it. Preservation is not a simple gift of depth. It depends on oxygen, temperature, sediment cover, salinity, biology, construction, impact damage, currents, and what the ship was carrying when it fell. The ship's human scale also becomes strange under the ROV lights. A porthole is familiar. A doorframe is familiar. A bollard, a winch, a section of railing, a deck opening, all of these are recognizable enough that the mind can imagine hands once using them. Then a fish passes through the same frame, unbothered by that recognition. The camera shows two scales at once: the scale of people who built and boarded the ship, and the scale of a deep ecosystem that absorbed it without needing to understand it. At Titanic's depth, the water belongs to the bathypelagic and abyssal transition of human imagination, even when the exact oceanographic categories are more specific than the word abyss can hold. There is no sunlight there. The only light in the footage is imported by the vehicle, or made briefly by living organisms in the water column. Food mostly arrives from above as marine snow, carcasses, fecal pellets, molts, and the remains of surface production. That means any hard structure on the bottom interacts with an energy-limited system. A wreck can concentrate life, but it does not create energy from nothing. It rearranges opportunity. On the seafloor around a wreck, the sediment may carry a microbial signal that extends beyond the metal itself. Studies of deep-sea wrecks have shown that microbial diversity and richness can increase near wreck material, suggesting an island-like effect in the seabed. This is not the same as saying the wreck is a coral reef full of visible animals. Much of the response is microscopic, chemical, and hidden inside sediment grains. The wreck's influence can be present where the camera sees only mud. That hidden influence is part of why deep wrecks are scientifically useful. They place known materials into an environment that is otherwise difficult to manipulate. A ship has steel, copper, paint, fuel residues, wood, ceramics, glass, rubber, and sometimes Cargo. It has surfaces in shade and surfaces exposed to current. It has vertical relief and enclosed cavities. It may sit across different sediment conditions. Researchers can ask how communities form on it, how corrosion advances, how pollutants behave, and how a hard object changes the biology of nearby soft sediments. But every deep wreck is also a site of loss, and the best exploration does not forget that. Many wrecks beyond reach are war graves. Others hold the traces of commercial crews, passengers, migrants, fishers, explorers, or people whose names were never recorded. A camera can move through these places with scientific purpose and still carry an obligation to restraint. The deeper a wreck lies, the easier it is to imagine that distance alone protects it. But distance is no longer complete protection. Salvage technology, private exploration, deep robotics, and market value can all reach farther than they once did. This is why documentation has become so important. A three-dimensional model can preserve the shape of a wreck without removing it. A careful survey can record changes over time. Non-invasive imaging can allow historians, archaeologists, biologists, and the public to study a site that should not be stripped for objects. In the deep sea, leaving a wreck in place is not neglect. Often it is the only respectful choice, because the site is not just a collection of things. It is the final arrangement of a history, and it has become part of the seafloor. Titanic remains powerful because it is familiar, but its deeper lesson is not fame. It shows that a ship can become a long experiment in corrosion, microbial life, deep sea colonization, heritage law, public memory, and technological reach. It shows that even a wreck visited many times is never fully known. The camera may return to the same bow, the same anchor, the same rail, and still find that the ocean has been working between visits, changing the ship in increments too small for drama and too persistent to ignore. The same lesson applies to wrecks with no famous name. A freighter lost in a convoy, a tanker broken by a torpedo, a fishing vessel that slipped from the shelf into deeper water, a wooden ship covered by sediment, an aircraft carrier resting beyond sunlight, all enter the same negotiations with depth. Their stories differ, their materials differ, their biological afterlives differ. What unites them is not tragedy alone. It is the fact that the deep sea takes objects designed for the surface and gives them new roles in a system that existed long before any ship was launched. To understand why these wrecks feel unreachable, it helps to follow the descent from the ship's point of view, not as a legend, but as a body moving through water. The surface may still be full of sound, waves striking plating, air escaping, fuel spreading, people in lifeboats or in the water, floating debris knocking together. Beneath that, the ship enters a blue zone where the last sunlight still has shape. Red fades first. Colors change. Objects that were painted for visibility become dull and altered. A name on a stern may remain physically present, but the light that made it readable is already being taken away. By 200 meters, the ship is passing through the twilight zone. This is not an empty transition. It is full of animals that rise and fall each day in one of the largest migrations on Earth. Lanternfish, bristlemouths, small squid, shrimp, siphonophores, and gelatinous animals occupy this water in layers that sonar can detect as if the ocean itself has a moving floor. A sinking ship crosses through them as an event too large to belong there. It sheds bubbles, splinters, oil, cargo, cloth, wood, and perhaps bodies, and every falling piece becomes a temporary point of interest in a world where food is often measured in particles. At 1,000 meters, the sunlight is gone. Below this depth, the ocean's visual world belongs mostly to darkness, bioluminescence, and the light brought by machines. A ship falling through this zone no longer looks like a ship in any normal sense. It is a mass moving through cold black water, and if animals sense it at all, they sense vibration, pressure changes, chemical traces, and disturbance. The pressure has increased enough that any remaining gas-filled space is under enormous stress. The ship was engineered against waves and weather, not against a vertical column of water thousands of meters tall. The descent does not have to be graceful. Sections can separate, funnels can tear away, masts can break, superstructures can collapse. A hull that floated as one object may reach the bottom as a field of related objects: boilers, anchors, guns, cargo, engines, dishes, bottles, shoes, shells, coal, timber, and personal items all fall according to their own shapes and densities. This is why debris fields matter. They are not merely scattered wreckage. They are a record of breakup, sinking behavior, currents, impact energy, and sometimes the final sequence of events that no witness on the surface could see. When the main hull reaches the bottom, the seafloor records it if the substrate is soft enough. It may gouge a trench. It may slide. It may strike bow first and buckle. It may settle upright in sediment, or roll, or collapse where internal strength has already failed. On a slope, gravity may continue working after the first impact, pulling sections downslope and stretching the wreck across depth contours. The wreck is not placed on the seafloor like an artifact on a table. It arrives with force, and that force becomes part of its archaeology. The animals already living there cannot leave an account, but they respond in the ways animals respond. Small fauna buried in sediment may be crushed or displaced. Scavengers may arrive if organic material is available. Fish may investigate the disturbance. Microbes begin using new chemical gradients. In a low-food environment, even a small pulse of organic matter can matter. A sinking can bring death to the bottom, but death in the deep sea is also energy. The remains of bodies, cargo, wood, food stores, leather, and natural fibers may be consumed long before the metal story is finished. In some ways, a shipwreck is like a whale fall, but only in the first rough outline. A whale fall is a body, rich in organic material, bone, oil, and tissue, and it supports a succession of scavengers, enrichment opportunists, sulfophilic communities, and bone specialists. A shipwreck may include organic material, but much of its long-term presence is mineral, metal, wood, and structure. Both can create islands on the seafloor. Both can alter local communities. But a wreck also brings industrial materials, human-made shapes, pollutants, and cultural meaning, none of which belong to a whale's ordinary ecological death. The shape of a wreck can be unusually valuable to animals because the deep seafloor is often starved of vertical relief. Many abyssal plains are not flat in a perfect sense, but they can be broad, soft, and low, with limited hard substrate. A hull, mast, anchor chain, or boiler changes the local flow of water. It creates eddies, shaded pockets, raised surfaces, and attachment points. For a coral larva drifting in a current, the difference between endless sediment and a piece of exposed metal can be the difference between no place to settle and a life spent above the mud. Not every wreck becomes visibly crowded. Depth, region, oxygen, current strength, larval supply, and material all determine what can live there. At some sites, the camera may show only a few fish, sparse anemones, bacterial films, and sediment. At others, especially where currents deliver food, the structure can carry dense growth. Deepwater corals may colonize hard surfaces. Sponges may rise from edges. Crinoids may hold their arms into the flow. A wreck's ecological importance is not measured only by how spectacular it looks in a single passive video. There are wrecks on continental shelves where sunlight still reaches or where divers can visit. Those can become lush artificial reefs with fish schools, algae, encrusting animals, and recreational histories. But the wrecks lost beyond human reach are different. They are not warmed by the sun. They are not cleaned by surge in the same way. They are not visited by ordinary divers who leave bubbles beneath a ceiling of water. They exist in pressure so high that the vehicle filming them has to resist forces that would destroy a submarine not designed for that depth. This is why the machines matter almost as much as the wrecks. An ROV is not just a camera. It is a pressure-resistant body, a set of thrusters, lights, navigation instruments, sonar, manipulator arms, sampling tools, telemetry, and a tether or fiber optic connection back to a ship that may be moving in waves far above. Its pilots do not feel the water directly. They feel it through lag, current, camera angle, and the behavior of the machine. A small mistake can stir sediment over a site, strike a fragile feature, snag a cable, or end a dive that cost days to prepare. A crude submersible changes the feeling, but not the limits. Inside the pressure sphere, people may look through a window at a wreck with their own eyes, but the window is small. The sphere is sealed, and the outside world is still lethal. The submersible does not make the deep ocean human. It makes a brief pocket of human survival inside it. Beyond the acrylic or glass or viewport, the water presses with a force that is not symbolic. It is physical, constant, and indifferent. Sonar often comes before vision because light travels poorly through water, and darkness means nothing to sound. A search team may spend days or weeks mapping the bottom, looking for shapes that do not fit the geology. A wreck can appear as a bright return, a shadow, a straight line, a mound, or a debris pattern. The first image may be abstract, almost disappointing, but to people who understand seabed mapping, a shadow at the right angle can be as meaningful as a photograph because it narrows the ocean from an enormous uncertainty into a possible place. Then comes the verification dive. The vehicle descends along coordinates derived from sonar, drift calculations, historical records, and the last known position. The water column passes for hours. The ship above may hold station using dynamic positioning, making constant adjustments against wind and current. In the control room, people speak quietly because loudness would not help. The bottom appears. The vehicle moves. At first there is sediment, then a line, then a shape too straight for rock, and the search becomes a meeting. Identification can depend on one detail: a hull number, a builder's feature, a gun mount, a pattern of rivets, a propeller, a cargo type, a bell if one remains visible and if it is appropriate to observe without removal. In very deep water, the identifying feature may be seen only through a short window of time before current, lighting, or navigation forces the vehicle away. This is why certainty often comes slowly. A wreck can be known, suspected, confirmed, reinterpreted, and documented across multiple expeditions. The ocean can hide ships even when the historical area is known. Navigation at the time of loss may have been uncertain. A battle may scatter vessels across a wide area. A storm may move survivors and debris away from the sinking point. Currents at different depths can push falling objects in different directions. A ship may slide after impact or break apart on a slope. The last known position is not always the final resting place. In the deep sea, a few nautical miles can mean years of searching. For wooden wrecks, the story can be very different from steel. In warm, oxygenated seawater, shipworms and other wood-boring organisms can reduce exposed timber with remarkable speed. But in very cold, deep, or oxygen-limited environments, wood may survive far longer than expected, especially if buried or if key wood-eating animals are absent. A carved stern, a deck plank, a mast, or even a painted name can remain visible in a place where the same ship might have vanished almost completely in shallower biological conditions. For metal wrecks, corrosion is not simply rust in the familiar land sense. It is an electrochemical and biological process shaped by oxygen, salinity, temperature, microbial activity, sediment contact, and the different metals used in the ship. Where steel touches sediment, one set of conditions may operate. Where it is exposed to moving water, another may dominate. Where copper, brass, aluminum, or lead are present, each behaves differently. A wreck is a complex chemical landscape, not one uniform object decaying at one uniform rate. Oil and fuel add another layer. Many 20th century wrecks still contain or once contained petroleum products, ammunition, chemicals, or cargo that may pose risks as the hull deteriorates. In shallow water, leaking fuel may be noticed quickly. In deep water, a release can be harder to detect, harder to respond to, and harder to monitor. The wreck is heritage, habitat, and potential pollution source at the same time. None of those identities is optional. This is especially important for wartime wrecks. The 20th century left ships across the deep ocean: destroyers, submarines, carriers, tankers, cargo vessels, landing craft, and aircraft. Many sank quickly, violently, and with fuel, munitions, and human remains aboard. Their locations may be legally protected, culturally sensitive, and biologically active. To film such a wreck is not the same as taking ownership of it. The best work approaches it as evidence, grave, and habitat, not as treasure. Treasure is often the wrong word for deep wrecks. It pulls the mind toward objects that can be recovered, sold, displayed, or possessed. But the value of a deep wreck is often in its arrangement, the position of the hull, the spread of the debris field, the corrosion patterns, the biological communities, the sediment around it, and the fact that it remains where history and ocean processes placed it. Remove too much, and the wreck stops being a place. It becomes a set of detached things. A camera pass can preserve more than a recovered object if the pass is careful. High-resolution photogrammetry can turn thousands of images into a three-dimensional model. Laser scales can measure features without contact. Environmental sensors can record temperature, oxygen, salinity, and current. Samples can be taken sparingly when they answer questions that images cannot answer. The future of deep wreck archaeology is not only deeper vehicles. It is better restraint, better mapping, better context, and better cooperation between historians, engineers, biologists, oceanographers, and the nations or communities connected to the loss. This cooperation matters because the deep sea is not outside human responsibility. It feels remote, but it is connected to shipping, fishing, climate, mining interest, military history, legal disputes, and public imagination. A wreck beyond human reach may still be within human impact. Trawls can damage sites, salvage can disturb graves, cables can cross debris fields. Changing ocean chemistry can alter corrosion and biological communities. Distance reduces casual contact, but it does not remove consequence. And yet, the first encounter with a deep wreck often remains simple. A light moves, a shape appears. People stop talking for a moment. It may be a famous vessel or an unknown one, but the feeling is similar because the ocean has taken something built for movement and made it still. Around it, life continues in small motions. A shrimp lifts from the sediment, a fish turns out of the beam, a white anemone opens in the current, and the ship begins to feel less like a lost object than a difficult part of the deep sea itself. One of the clearest examples of preservation depending on environment is Endurance, the ship of Ernest Shackleton's Antarctic expedition. It did not sink in a tropical sea or on a busy coast. It was crushed by pack ice in the Weddell Sea in 1915 and later found at a depth of just over 3,000 meters. The discovery footage surprised many people because the ship looked almost impossibly intact. The stern still carried its name. Timbers still held form. The wreck did not look untouched, but it looked legible in a way few wooden vessels do after more than a century underwater. The reason is not magic and not simply cold. The Weddell Sea is cold, remote, and covered by ice for much of the year. The conditions there are difficult for many organisms that destroy wood in shallower, warmer marine environments. Wood-boring shipworms, which can devastate wooden wrecks in other places, are not the same force in those Antarctic depths. This does not mean the wreck is safe forever. It means that the local ecology, chemistry, temperature, and isolation slowed the usual disappearance of timber enough for the ship to remain readable to cameras after generations. The search itself shows another form of beyond reach. Endurance did not lie at the greatest depth, but it lay beneath one of the most difficult surfaces on Earth, moving sea ice. To find it, an expedition had to work from an icebreaker and deploy underwater vehicles in conditions where the ceiling above the ocean could shift, close, and threaten the connection between machine and ship. Depth alone is not the only barrier. Ice can be a barrier. Weather can be a barrier. Distance from rescue can be a barrier. A wreck can be unreachable because the water is deep, or because the surface above it is almost as hostile as the bottom below. When the vehicle finally saw Endurance, the image carried more than polar history. It showed how deep sea animals had accepted the ship into their environment. Anemones and other organisms were visible on parts of the wreck. The wood was not a clean museum surface, it was a substrate. The ship remained historically recognizable, but it was already integrated into the seafloor community. Even the best preserved wreck is not outside biology. It is only experiencing a different rate and kind of biological change. Endurance also reminds us that a wreck's meaning is sometimes shaped by survival rather than death. Shackleton's crew survived the loss of the ship, and so the wreck is not a mass grave in the same way as many wartime or passenger disasters. But the ship still marks the end of an ambition, the failure of a route, the beginning of a survival story, and the transformation of a working vessel into a deep polar object. The ocean kept the ship after the people left, and for more than a century the only witnesses were animals, sediment, ice, and water. In a warm, shallow sea, the same ship might have become an outline of metal fastenings, ballast, and scattered durable objects. In the Weddell Sea, it retained a form that allowed people to recognize the stern almost immediately. This is why archaeologists resist simple rules. Wooden ship, steel ship, deep water, cold water, low oxygen, high current, burial, exposure, biological attack, and human disturbance all interact. Preservation is a local outcome. It is a result of the wreck meeting a particular environment, not a guaranteed property of age or depth. The deep sea often preserves by slowing. Low temperature reduces reaction rates. Darkness prevents photosynthesis and the growth forms that depend directly on sunlight. High pressure changes animal and microbial physiology. Food scarcity limits the abundance of many organisms. But none of this means the deep sea is inactive. In the beam of a vehicle, the action may be small: a starfish on a plank, a faint layer of sediment, a white animal attached to a rail, a fish crossing the background. Over time, those small actions are enough to rewrite the surface of a ship. Endurance's preservation also created a public illusion of closeness. High-definition footage made it feel as if the ship had been brought back. People could see details with more clarity than anyone on deck could see during the sinking. But clarity is not access. The wreck remains in the Weddell Sea, beneath deep water and ice, protected as heritage, reachable only by advanced equipment and careful planning. What has been recovered is not the ship itself, but a record of its presence. This difference matters for all deep wrecks. A camera image can make a site emotionally immediate, but the site itself remains remote. The monitor collapses distance for people watching, while the vehicle outside the ship experiences distance as pressure, cold, darkness, and limited time. The screen is intimate, the ocean is not. Other preserved wooden wrecks tell similar but not identical stories. In the Black Sea, low-oxygen deep waters have preserved ancient wooden vessels in extraordinary condition. In high-latitude seas, cold can slow decay. In buried contexts, sediment can isolate material from oxygen and borers. Each case is specific. The deep ocean does not preserve history as a rule. It preserves some histories under some conditions and erases others completely. The ships that vanish leave evidence too, but the evidence may be harder to read. A wooden hull may disappear while ceramic cargo remains. Iron fastenings may mark the pattern of a vessel whose planks are gone. Amphorae can outline ancient trade routes after the wood that carried them has been consumed. Coal piles, ballast stones, anchors, guns, engines, or cargo ingots can remain when the ship's form is lost. A wreck is not always the shape of a ship. Sometimes it is the pattern left by what resisted the ocean longest. This is one reason the word shipwreck can be misleading. It suggests a single object, a broken ship. But in deep archaeology, a wreck may be a scatter, a mound, a stain, a chemical anomaly, a magnetic signature, or a line of objects laid across a slope. It may not look cinematic at all. The ocean does not arrange evidence for storytelling. It leaves what physics, chemistry, and biology allow to remain. For a narrator, the challenge is to respect that plainness. Not every wreck is a ghost ship. Not every descent reveals a bow rising from darkness. Sometimes the most important image is a field of jars, a boiler protruding from sediment, a broken engine, a propeller half buried, or a piece of wood too degraded to carry shape. The deep sea asks us to value fragments, because fragments may be the only honest record left. Deep wrecks also carry time differently from fossils. A dinosaur bone in rock belongs to geological time, mineral replacement, and sedimentary burial over millions of years. A shipwreck may be only decades or centuries old, close enough that its construction drawings, crew lists, cargo manifests, or radio messages may survive in archives. Yet the wreck's environment can feel as remote as any ancient world. It is recent history placed in a habitat that operates on slow, unfamiliar terms. This mixture of recent and remote is part of what makes deep shipwrecks so powerful. The ship may contain electric wiring, modern steel, canned food, glass bottles, printed labels, machine tools, radar equipment, or personal objects that still belong recognizably to the modern world. Around them are animals living without sunlight, microbes using chemical gradients, and currents that do not care whether the object is ancient or new. The human past is not protected from becoming habitat. At Endurance, the absence of removal was central to the discovery's meaning. The vehicle documented the wreck without disturbing it. That restraint allowed the ship to remain a site rather than a source of trophies. For deep wrecks, this approach is increasingly important because technology now makes it possible to reach places that were once naturally protected by depth. When reach expands, ethics has to expand with it. The deep sea is full of things that cannot defend themselves against curiosity. A coral colony may grow for centuries and break under one careless contact. A microbial mat may be disturbed by a thruster. A wreck feature may be knocked loose by a manipulator arm. Even bright lights and repeated visits can change animal behavior in small ways. Exploration is not harmless simply because it is scientific. It becomes responsible only when the questions are worth the intrusion and the methods are as gentle as the site requires. In polar wrecks, the surface risk adds another pressure. Ice conditions can trap ships, threaten vehicles, and limit the weather windows for work. A lost vehicle can become debris. Fuel burned to reach the site has its own environmental cost. The romance of discovery can obscure the logistics that make discovery possible. Behind each image of a wreck is a chain of navigation, engineering, funding, permits, weather forecasting, ice analysis, crew labor, and risk management. This is true even when the footage looks quiet. The camera glides over the stern. The name is visible. A sea star rests nearby. The lighting is steady. Nothing in the frame shows the icebreaker, the control room, the team watching navigation data, or the years of research that narrowed the search area. Deep sea footage often looks simple because the machinery of access has been kept just outside the frame. Endurance is therefore not only a story of a ship found, it is a story of the deep ocean as a selective archive. It kept a wooden vessel in conditions that slowed destruction, but it did not bring it back. It let the ship become visible again without becoming available. That may be the most honest kind of discovery, not possession, not rescue, but recognition from a distance. Some wrecks are beyond reach, not because they are old, but because they were born from violence and then placed by gravity in water too deep for ordinary return. The German battleship Bismarck lies in the North Atlantic at a depth of roughly 4,800 meters, a depth where the wreck is not a diving destination, but a remote survey subject. At the surface, its story is naval pursuit, shell fire, torpedoes, flooding, scuttling debates, and the final hours of a warship. On the bottom, the story becomes one of impact, preservation, corrosion, and a huge armored body resting in a cold landscape of sediment. A battleship is built to endure attack, but it is not built to sink gently. Armor belts, turrets, machinery spaces, shafts, and structural compartments all carry different strengths and weaknesses. When such a vessel reaches the seafloor, the heavy components do not simply stop being heavy. They settle, strain, twist, and sometimes separate. A gun turret may fall away because it was held in place by gravity when the ship was upright. A superstructure may collapse because it was never designed to support itself under the forces of sinking and impact. The wreck is an engineering autopsy, but one performed by the sea. In deep footage of large warships, the scale can be hard to interpret because the camera often lacks familiar reference points. A deck plate fills the frame. A porthole appears. A gun barrel emerges from darkness and then vanishes behind the vehicle's angle. Without people standing nearby, the mind struggles to measure size. The ship was once a machine large enough to carry thousands of tons of steel across the surface. On the seafloor, it becomes terrain. The RUV does not tour it as one tours a vessel. It navigates it like a cliff, a canyon, a ruin, and a hazard. Warships also bring the question of damage into sharper focus. A shell hole, torpedo impact, bent armor, torn plating, or missing section can connect the wreck to accounts of battle. But interpretation is difficult. Damage may come from the battle, from internal explosions, from breakup during sinking, from seafloor impact, or from later collapse. The deep wreck does not speak in a single voice. It presents marks, and researchers have to decide which marks belong to which moment. This is why deep wreck documentation often moves slowly between image and archive. A feature seen on the bottom is compared with ship plans, battle reports, survivor testimony, photographs, and previous surveys. The goal is not to force the wreck to confirm a preferred story, but to let the material evidence revise or complicate what was believed. A shipwreck can settle arguments, but it can also open new ones because the seafloor preserves evidence without explaining it. Around Bismarck and wrecks like it, the deep sea environment continues its own work. Fish may pass over the hull. Anemones or other attached animals may occupy exposed surfaces. Sediment may build against the lower sections. Corrosion may thin parts of the steel, while heavier armored areas remain recognizable. The wreck is massive, but even massive objects are not immune to time. The deep sea does not need to destroy quickly to destroy completely. It only needs to keep working. Large warships can also create complex habitat because they offer many forms at once. Vertical walls, overhangs, cavities, railings, cables, guns, ladders, deck openings, and debris. Some animals prefer exposed current, others use crevices. Some attach to edges, while others move through shadows. A wreck can create microhabitats within meters of one another. To a small deep-sea animal, the difference between the outside of a hull and the inside of a broken compartment may be as important as the difference between a forest edge and a burrow. At nearly 5,000 meters, however, food is limited. The wreck can concentrate life, but the animals still depend on energy arriving through currents, falling particles, occasional carcasses, or local microbial processes. The dramatic human object does not exempt the ecosystem from scarcity. A fish using a wreck for shelter still has to find prey. A coral growing on metal still depends on water movement to bring food. A crab walking over a deck still belongs to the slow arithmetic of deep-sea energy. The emotional weight of a warship can make it easy to see only human conflict, but the biology helps restore scale. The ocean floor is not a memorial hall. It is a habitat that has taken in the remains of human conflict and continued. This does not reduce the loss. If anything, it makes the loss more exact. The people are gone, the politics have changed, the weapons are silent, and the animals living there are engaged in the ordinary work of feeding, avoiding danger, reproducing, and dying. A deep wreck can be upright and still ruined. It can be recognizable and still unstable. It can look peaceful and still be filled with the evidence of violence. This combination is common in deep-sea imagery because the lack of surface motion removes the obvious signs of chaos. There are no waves breaking over the deck. There is no smoke. The stillness can deceive the mind into thinking the wreck is calm, when in fact, it is the final arrangement of enormous forces. Bismarck's depth also places it below the ordinary cultural reach of the nations that fought over it. It cannot be visited by veterans, families, tourists, or divers. It cannot be maintained. It cannot be guarded in the familiar way. Its protection depends on law, secrecy, respect, and the limits of equipment. The wreck remains where it is, partly because removal would be technically difficult, partly because removal would be ethically wrong, and partly because the deep sea itself resists casual interference. Other warships lie shallower and have suffered from salvage, looting, or accidental damage. Some have been stripped for metal. Some have been entered by divers. Some have been damaged by fishing gear. The deep wrecks avoided much of that for decades because no one could reach them easily. But this natural protection is weakening as technology improves. A site that once lay beyond practical reach may become accessible to a private vehicle, a commercial survey, or an unauthorized recovery attempt. This creates a strange race between documentation and disturbance. Archaeologists and ocean scientists want to record sites before they collapse or are damaged. Families and nations may want them left in peace. Salvors may see value in objects. Filmmakers may seek images. Engineers may see technical challenges. The wreck itself cannot choose which form of attention comes first. The best deep wreck surveys therefore carry a discipline that is almost opposite to treasure hunting. They avoid unnecessary contact. They treat artifacts as part of context. They map before interpreting. They document living communities as well as human-made features. They recognize that a hull plate covered in animals is not merely an obstacle to seeing the ship. It is part of what the ship has become. Biology is not a stain on archaeology. In the deep ocean, biology is one of the main processes writing the wreck's second history. This second history can be much longer than the first. A warship may serve for only a few years. A merchant vessel may cross the ocean for decades. But once it sinks into deep water, its breakdown and ecological incorporation may continue for centuries. The human period of use is brief compared with the seafloor period of transformation. A ship may spend almost all of its existence not as a ship, but as a wreck. The same is true for weapons on the seafloor. A gun built for a battle becomes a perch. A torpedo tube becomes a shadowed cavity. Shell holes become openings for animals. Ammunition may become a hazard as casings corrode. The tools of human violence are not erased by the ocean, but they are repurposed by processes that have no allegiance to the reason those tools were made. When ROV lights pass over such a site, the camera may reveal details that feel almost too intimate. A ladder bent against a wall, a hatch partly open, a cable draped across sediment, a boot sole, a dish, a small object that implies a person more strongly than the largest gun. These details have to be handled carefully. They are not decorations. They are the scale at which history becomes individual. Yet deep-sea animals will still cross the frame. A rattail may approach the light, turn, and vanish. A shrimp may rise with a flick. A white sponge may grow from metal that was forged for war. This is not disrespect from nature. Nature has no category for respect. Respect belongs to the observer, to the choices made about how to film, what to touch, what to remove, and what to leave. The deep war wreck, therefore, becomes a meeting between memory and indifference. Human memory says this place matters because of what happened here, who died here, and what the ship meant. Ocean indifference says the site is material, surface, chemistry, shelter, and disturbance. A responsible view has to hold both truths at once. If it sees only memory, it ignores the living deep sea. If it sees only habitat, it ignores the people who never came home. Bismarck is not alone in this category. Across the Atlantic, Pacific, Indian Ocean, Arctic approaches, and Mediterranean depths are vessels that represent trade, empire, war, migration, exploration, exploitation, rescue, and failure. Many have never been found. Some will never be identified. Some lie under sediment or on slopes too difficult to survey. The seafloor is not a single archive with open shelves. It is an archive scattered across darkness, pressure, and terrain. The deeper the wreck, the more likely it is that discovery will come from a combination of history and geophysics. A search team needs old coordinates, but also an understanding of currents, sinking dynamics, bathymetry, and equipment limits. A reported position from a battle may be imprecise. A wartime log may contain errors. A survivor's memory may be accurate emotionally, but uncertain geographically. The deep ocean is too large for hope alone. It requires narrowing, mapping, and then patient verification. When the wreck is finally seen, there is often no triumphant ending. The discovery answers where, sometimes how, sometimes what happened after the last report. But it does not undo the loss. It does not return the ship to the surface. It does not stop corrosion. It does not make the site simple. It only changes the wreck from an absence into a place. And once it becomes a place, it belongs to more than one field of study. Historians see evidence. Naval architects see failure and endurance. Biologists see colonization. Microbiologists see metal, sediments, and communities. Oceanographers see currents and bottom conditions. Families see a grave. People see a shape in darkness. The wreck is one object only from a distance. Up close, it is many stories occupying the same coordinates. If Titanic shows the deep sea as a place beyond ordinary diving, the wrecks off Samar show something farther still. The destroyer US Johnston and the destroyer escort US Samuel B. Roberts went down during the battle off Samar in 1944, and their wrecks lie in depths that push into the Haddle scale of the ocean. Johnston was identified at about 6,456 meters. Samuel B. Roberts was later located and surveyed at about 6,895 meters. These are not merely deep wrecks. They are wrecks at the edge of what many ocean systems can reach. The difference between 4,000 meters and nearly 7,000 meters is not just a number, it is hundreds of additional atmospheres of pressure. It is a shift from abyssal depth into the trench world, where the seafloor can fall away into immense submarine topography, and where vehicles must be designed for forces that leave little margin. Many deep ocean tools historically work to around 6,000 meters, because that range covers most of the global seafloor. A wreck deeper than that enters a category where ordinary deep-sea capability may not be enough. This is part of why Johnston remained only partly known after its first discovery. Earlier ROV work found wreckage of a Fletcher-class destroyer at extraordinary depth, but the main section lay deeper than the vehicle could safely investigate in full. The ocean had placed the identifying evidence just beyond the machine's rating. That is what beyond human reach can mean in practice. Not that the wreck is supernatural or unknowable, but that a few hundred meters of additional depth can separate suspicion from confirmation. When later dives reached Johnston and saw the hull number, the wreck became more than a possible identity. The number made the ship itself visible through the evidence. turrets, bridge features, and structural damage could be documented. The ship's final battle could be connected to the arrangement on the seafloor. A white number painted for recognition in war had survived long enough to identify the ship in a darkness no lookout could ever have imagined. Samuel B. Roberts went deeper still. Its wreck, found in two main sections, became the deepest identified and surveyed shipwreck known. The phrase is easy to say, but the depth is difficult to feel. 6,895 meters is not a depth that a person can picture by looking down from a cliff or a mountain. It is water piled higher than most mountains are tall, pressing on every surface, filtering out all sunlight, and separating the site from the surface by hours of descent. At that depth, even visiting is an expedition into engineering limits. The battle off Samar belongs to naval history, but the wrecks belong now to a seafloor environment where the war is over in every biological sense. The guns are silent. The decks no longer carry crews. The hulls no longer respond to engines or steering. Around them, hadal and abyssal animals move through sediment and current according to needs that have nothing to do with 1944. A fish passing the bow does not know courage. A brittle star on a plate does not know sacrifice. The meaning is ours, and the habitat is theirs. This separation is not coldness. It is clarity. Human beings bring memory to deep wrecks, because memory is one of the things we are. Animals bring hunger, shelter-seeking, chemical sensing, reproduction, and avoidance of predators, because those are the conditions of their lives. The same object can be a grave to one species and a hard substrate to another. The deep sea does not resolve that tension for us. At nearly 7,000 meters, the visible animal community may be sparse compared with shallower reefs, but it is not absent. Amphipods can be abundant in trenches. Holothurians may move across sediments in many abyssal and hadal regions. Grenadiers and other deep fish appear in certain settings, though the composition depends on depth and region. Microbes are present on surfaces and within sediment. The ship provides material and relief, but the extreme depth limits which organisms can use it and how quickly visible colonization develops. The pressure also changes the way we imagine the wreck. At shallow depth, a wreck can be entered, touched, sketched by hand, and surrounded by bubbles. At Samuel B. Roberts depth, the presence of people depends on a submersible pressure sphere and the exact functioning of seals, batteries, syntactic foam, navigation, and life support. There is no casual action. There is no simple return. Every minute at the wreck is purchased by design, risk, and years of accumulated deep ocean experience. The animals living there do not experience pressure as an obstacle in the way we do. Their bodies are adapted to it. Many do not contain the gas-filled spaces that make pressure so dangerous to us. Their enzymes, membranes, and cellular processes operate under conditions that would be fatal to surface organisms. The wreck is beyond human bodies, but not beyond life. That distinction is central to the deep sea. In hadal regions, the seafloor is often shaped by trenches and steep slopes, not broad flat plains alone. This matters for wrecks because a ship lost above a trench can come to rest on a slope, break apart, slide, or settle into sediment at different depths. The wreck may not be a neat object waiting on a level bottom. It may be stretched along terrain, with pieces separated by impact and gravity. The deep ocean is not a bathtub with a flat floor. It is mountains, canyons, escarpments, trenches, plains, and sedimented slopes underwater. The military records of ships like Johnston and Samuel B. Roberts are detailed by human standards, but the seafloor adds evidence no report could fully contain. Damage visible on a hull may align with shell fire. The orientation of guns may suggest the last direction of action, though interpretation must be cautious. The way a stern separated or a bow buckled may reveal impact energy. The wreck does not replace testimony, but it gives testimony a material counterpart. These wrecks also show how deep sea discovery can revise public understanding of what has survived. For decades, ships lost in very deep battle areas could be thought of almost abstractly, as positions on a chart or names on memorials. Once imaged, they become physical again. A gun mount appears, a bridge structure remains, a hull number is readable. The ship has not returned, but the imagination no longer has to stand over empty coordinates. That return through imagery can be powerful and dangerous. Powerful because it connects living people to a place that seemed permanently removed. Dangerous because the image can create the illusion that the wreck now belongs to people watching. It does not. The deeper a war grave lies, the more important it is to remember that seeing is not owning, and documenting is not permission to disturb. At these depths, the sea itself has been a guard. Unauthorized salvage is difficult. Recreational diving is impossible. Weather, distance, and cost limit visits. But technology moves forward. What was impossible in one generation becomes difficult in the next, and routine in a specialized field later. The ethical status of a wreck cannot depend only on being hard to reach, because difficulty changes. The wrecks off Samar are also part of a larger pattern. The Pacific contains many deep wartime losses, some in waters that are among the deepest on Earth. Naval battles were fought over island arcs, trenches, slopes, and basins. Ships that vanished from the surface often entered complex seafloor terrain. Their discovery requires not only naval history, but also bathymetry, geology, and deep submergence engineering. The debris fields can be enormous or compact depending on how the ship sank. A vessel that explodes or breaks up near the surface may scatter objects over a wide area. A vessel that remains mostly intact until impact may create a smaller but more concentrated site. On steep slopes, pieces can continue moving after impact. The distance between debris is a clue, but not a simple one. It must be read with an understanding of water column drift, breakup, current, and bottom terrain. At the deepest wrecks, even the light behaves differently to human eyes because the darkness is absolute. The vehicle's lamps reveal only what they strike, and beyond the beam there is no horizon. A gun barrel or bow edge may appear without context, then disappear as the vehicle moves. The wreck is not seen all at once. It is assembled in memory from passages of light. This fragmented view resembles the way deep history often works. No one gets the whole ship in one glance. Researchers build it from sonar, video, still images, navigation tracks, measurements, and models. People build it from edited footage. Families build it from memory and records. The deep sea gives pieces, and people make careful maps from them. There is also humility in the fact that the world's deepest known wreck is a relatively small warship, not an enormous liner or battleship. The ocean does not rank human stories by size. A destroyer escort can sink deeper than a famous passenger ship. A small vessel can rest in a place that tests the limits of exploration more severely than the wreck of a giant. Depth is not proportional to fame. The deepest wrecks remind us that there are likely many ships still unseen at similar or greater depths. The ocean covers battlefields, trade routes, storm paths, migration routes, fishing grounds, and polar passages. Some wrecks are known only from loss records. Some may be mislocated. Some may be buried. Some may be too damaged to identify even if found. The fact that a wreck has not been seen does not mean it is gone. It may simply be resting in a part of the seafloor where our search has not yet passed. At Haddle depth, the human imagination often reaches for words like abyss, but the animals living there do not inhabit an idea. They inhabit gradients of pressure, food, oxygen, temperature, topography, and chemistry. A wreck entering that world is not falling into emptiness. It is falling into a habitat that is difficult for us to observe and normal for its inhabitants. The limits are ours, not life's. This is the central reversal of deep shipwrecks. The ship begins as a symbol of human control over distance. It crosses oceans, carries weapons or passengers or cargo, follows charts, burns fuel, receives orders, and moves through weather. Then it sinks into a place where control belongs to pressure, current, corrosion, microbes, and animals. Beyond human reach, the ship stops being proof of mastery and becomes evidence of limits. But limits are not failure in a simple sense. They are also what make careful exploration meaningful. The fact that a wreck can only be reached briefly makes each observation valuable. The fact that the environment is hostile to us makes the adaptations of its animals more remarkable. The fact that history survives there at all makes preservation feel less like possession and more like a temporary chance to learn. A deep wreck is not waiting for us. We are the ones who arrive late. To see a wreck as habitat, begin at the smallest scale. Before a coral, sponge, crab, or fish uses the structure, microbes arrive. They form films on metal, wood, paint, glass, and sediment. They respond to iron, sulfur, carbon, hydrocarbons, oxygen gradients, and the minute differences between exposed and buried surfaces. These films are easy to overlook because they do not give the camera a dramatic silhouette, but they influence what follows. Larvae may settle more easily on certain microbial films. Corrosion may be accelerated or redirected by microbial metabolism. Sediment chemistry may change near the wreck. A steel plate lying in deep water is therefore not just a passive object. It is a surface where chemistry, biology, and engineering meet. The composition of the alloy matters. The paint matters. The damage matters. The amount of oxygen matters. Whether the plate is vertical, horizontal, buried, or exposed matters. A shipwreck is made of many habitats because it is made of many surfaces and many conditions pressed into one site. After microbial films come early colonizers, though the exact sequence depends on the location. Some larvae drift for days or weeks before settling. Others arrive from nearby hard substrate if currents connect the wreck to natural outcrops, reefs, seeps, canyon walls, or oil platforms. Hydroids, anemones, bryozoans, tubeworms, barnacles, sponges, corals, and other sessile animals may claim space where they can survive. On a wreck, the first attached animals are not decorating it. They are changing the flow, texture, and biological invitation of the structure. A small anemone on a railing creates a feeding surface where none existed. A sponge filters water and provides texture for small animals. A coral colony adds branches that can shelter brittle stars, shrimp, and juvenile fish. Tube-building organisms create roughness. Microbial mats trap particles. The habitat becomes more complex as life accumulates, but it remains limited by food supply, current, oxygen, depth, and the stability of the structure beneath it. Mobile animals then use the wreck in ways that can be difficult to categorize. A fish may not live on the wreck permanently, but it may visit it repeatedly because prey concentrate there. A crab may forage along edges. An octopus may den in a cavity if the depth and regions suit it. Amphipods may gather where organic material is trapped. Squat lobsters may perch in current. The wreck becomes less like an object and more like a neighborhood, though not a crowded one, and not always a permanent one. The island effect is a useful idea, but it has limits. A wreck can act like an island of hard substrate in a soft-bottom sea, but unlike a natural island, it brings industrial chemistry and a human history. It may support more diverse microbial communities near its structure than in surrounding sediment, and its influence may fade with distance. But it should not be imagined as a simple oasis. It can enrich, disturb, contaminate, shelter, corrode, and fragment at the same time. In the Gulf of Mexico, deep-water wrecks have been studied partly because they offer a way to understand artificial hard-bottom habitats. The Northern Gulf has natural seeps, carbonate outcrops, deep coral communities, oil and gas infrastructure, and many historic shipwrecks. This makes it a complicated region where natural and human-made structures can both provide attachment points for deep animals. A wreck in such a setting may be one node in a broader network of hard surfaces connected by currents and larval dispersal. This network idea matters because many deep-sea animals cannot move freely as adults once attached. Their larvae must find suitable places to settle. If hard substrate is rare, the distance between surfaces can shape populations. A wreck may become a stepping stone, allowing species to occupy places they might not otherwise reach, or it may simply attract larvae already moving through the region. The wreck is not isolated from ocean circulation. It is stitched into it. Current can make the difference between a bare wreck and a living one. Where water flows steadily across a structure, suspended food reaches filter feeders. Sediment may be kept from burying surfaces. Chemical gradients may remain active. Where current is weak, fine particles settle, surfaces can silt over, and attached animals may be limited. The same ship, resting in a different current regime, might support a different community. Depth also determines what kinds of animals are possible. In the twilight zone, mobile animals may connect the wreck to daily vertical migration. In the midnight zone, bioluminescent organisms pass through darkness above the bottom, and the wreck may sit beneath a rain of particles from the water column. On abyssal plains, seafloor life is often sparse and slow, shaped by limited food. In trenches, pressure restricts many groups and favors those adapted to hadal conditions. A wreck carries its own structure, but it cannot carry its own ocean. The deep sea also changes scale. A single orange roughy or grenadier beside a steel plate may seem lonely on camera. But that does not mean the habitat is meaningless. In an environment where distances are large and food is dispersed, a wreck may be used intermittently by animals over years. The camera records a moment. Ecology requires time. Time can be difficult for people because many deep-sea processes are too slow for ordinary attention. A coral colony may grow slowly. Sediment may accumulate millimeter by millimeter. Corrosion may thin a plate over decades. Microbial communities may change seasonally or with oxygen conditions. A debris field may look unchanged between visits even as chemistry shifts beneath it. The deep ocean's drama is often not speed. It is persistence. Some wrecks produce more obvious biological scenes. A hull can be covered in white anemones, creating the impression of a ghostly garden. Fish may gather around openings. Sponges may stand like small towers. Crabs may move across decks. But even there, the image is only part of the story. The animals seen in the lights are the visible layer of a system that also includes bacteria, dissolved metals, trapped particles, sediments, and chemical exchanges. The materials of a wreck can attract or repel different life. Copper alloys can inhibit some fouling organisms. Iron can feed certain microbial processes. Wood can support organisms able to digest it, if they are present. Paints may contain toxic compounds. Fuel residues can support hydrocarbon-degrading microbes while posing risks to other organisms. A ship is not neutral habitat. It is a complicated mixture of opportunities and hazards. This is one reason intentional artificial reefs must be prepared carefully before sinking. Hazardous materials are removed. Fuels are cleaned. Loose debris is managed. The goal is to create structure without unnecessary contamination. Historic wrecks did not receive that preparation. They sank with whatever they carried, in whatever condition the disaster left them. The ocean inherits not only the hull, but also the consequences of the ship's use. Deep wrecks can trap organic matter in ways natural sediment may not. A room, hatch, or collapsed passage can catch falling particles, animal remains, or drifting debris. This creates small enrichment zones. Scavengers may find food there. Microbial activity may increase. Sediment inside the wreck may differ from sediment outside. A cabin floor can become a tiny basin of deep-sea chemistry. The wreck's vertical surfaces can also lift animals into better flow. Filter feeders often benefit from elevation because water movement brings suspended food. A coral on the top of a railing may feed better than one smothered near the sediment. A crinoid perched on a mast fragment can extend its arms into current. Height is valuable in the deep sea because food arrives with water movement, and structure gives animals access to that movement. Predators may use the wreck indirectly. Small animals attracted to the structure can attract larger ones. A fish that hides near a hull may be hunted by another fish. An octopus using a cavity may feed on crustaceans drawn to the site. A shark or larger deep predator may pass by because chemical or movement cues concentrate there, though such visits may be rare and difficult to observe. The wreck does not create a separate food web. It bends the surrounding food web around itself. There is also the question of sound and vibration. Wrecks can alter local flow, and moving water across openings or loose features may produce subtle vibrations. Animals sensitive to motion or pressure changes may respond, though direct evidence varies and should not be exaggerated. Much of deep-sea animal behavior around wrecks remains observed only in fragments. The camera shows presence more often than motive. The life on a wreck can mislead people watching into thinking the ship has been healed. Growth covers damage. Corals make edges beautiful. Fish soften the image of war. But colonization is not repair. It does not restore the people, undo the sinking, or neutralize pollutants. Habitat and harm can occupy the same object. The fact that animals live on a wreck does not mean the wreck was good for the sea. At the same time, life on wrecks can reveal resilience. Given a surface, a current, and enough time, deep organisms may use structures never meant for them. They do not need the object to be natural. They need it to meet the requirements of attachment, shelter, feeding, or reproduction. The ocean is not sentimental, but it is opportunistic in the most literal biological sense. This opportunism does not make all wrecks equal. A clean steel framework placed intentionally may differ from a torpedoed tanker leaking oil. A wooden sailing ship buried in low-oxygen sediment differs from a modern warship with ammunition aboard. A wreck in a high-current canyon differs from one on a quiet abyssal plain. Each site has its own ecology because each site has its own materials, history, and setting. For scientists, the challenge is to separate attraction from production. Are fish gathering at a wreck because the wreck produces more food, or because it concentrates animals that would otherwise be spread out? Does the structure increase local biodiversity or simply make it easier to see? Do microbial communities near a wreck represent enrichment, contamination response, or both? These are not simple questions, and they matter for how we interpret artificial reefs and human structures in the deep sea. Deep-sea shipwrecks can therefore serve as unintended experiments. No one designed most of them for science, but their known dates of sinking, known materials, and fixed locations allow comparisons across time. A wreck sunk in 1942 and another in 1912 may show different stages of corrosion and colonization. Wrecks at different depths reveal how pressure, temperature, oxygen, and currents shape decay. The tragedy of loss becomes, carefully and respectfully, a source of knowledge about the hidden ocean. That knowledge should not make the wreck only scientific. It should make it more complete. The same structure can teach us about corrosion and still be a grave. It can host animals and still be protected heritage. It can be visually beautiful and still be evidence of disaster. The deep sea does not simplify objects for us. It layers meanings until the observer has to become more careful. In the end, the ecology of shipwrecks changes the title itself. Ships lost beyond human reach are not beyond reach for bacteria, larvae, currents, scavengers, or time. They are beyond the easy reach of our hands. They are not beyond the reach of the ocean. The ocean reaches them constantly through pressure, chemistry, animals, and the slow fall of snow from the lighted world above. Most shipwrecks beyond human reach will never become famous. They will not have a single image known around the world, or a name that makes people watching pause before the footage begins. They may be listed in archives as missing, presumed sunk, lost with all hands, overdue, wrecked in weather, torpedoed, mined, or vanished. Their exact positions may be uncertain. Their cargo may be poorly recorded. Their crew lists may be incomplete. Yet each one entered the same physical transformation, a surface vessel becoming a deep sea object. The ocean floor is crossed by the remains of trade. Ships carried coal, grain, oil, timber, ore, ceramics, textiles, weapons, machinery, food, rubber, tea, silver, people, animals, mail, and the ordinary objects of daily life. When they sank, the cargo did not become abstract. It scattered, dissolved, burst, floated, sank, or preserved according to its material. A cargo of amphorae may survive for millennia. A cargo of grain may become a brief feast. A cargo of oil may become a long hazard. A crate of machinery may outlast the hull that held it. Trade routes matter because wrecks do not fall randomly across the seafloor. They cluster along paths people used repeatedly, approaches to ports, wartime convoy routes, straits, capes, island passages, fishing grounds, whaling routes, and polar ambitions. Deep water near these routes can hold wrecks from many centuries stacked not vertically, but historically, with one era's loss resting miles from another's. The seafloor becomes a map of human movement written in accidents. Some deep wrecks are lost because the surface was ordinary until it was not. A storm builds. A hull takes water. A navigation error places the vessel over a slope. A fire starts in a cargo hold. A mine detonates. A submarine attack comes without warning. An engine fails in weather too heavy for rescue. The descent into the deep is often the last chapter of a chain of smaller failures, each one understandable, each one insufficient alone, until together they exceed the ship's ability to remain afloat. Other wrecks were lost in places already known to be dangerous. Narrow straits concentrate traffic and currents. Continental margins hide canyons and steep drop-offs. Polar seas crush and trap. Volcanic island arcs bring deep water close to shore. War zones turn routes into hunting grounds. A ship may be lost not because the ocean is mysterious in a vague sense, but because geography, weather, machinery, and human decisions intersected badly at a specific place. The deep sea keeps these intersections unevenly. A ship that sinks near a submarine canyon may be partly buried by sediment flows or carried downslope after impact. A ship that falls onto a hard slope may break apart and leave debris over a wide depth range. A ship on an abyssal plain may remain more spatially coherent, though still altered by impact. The final wreck site is not only the location of sinking, it is the result of what happened between the surface and bottom. This is why the debris field can be more revealing than the most recognizable piece. A person may want the bow, the bridge, the name, or the gun. Archaeologists look also at the small objects, the distribution, the directionality, the concentration of heavy material, and the relationship to terrain. A wreck's story is often written in where things are not, as much as where they are. A porcelain cup far from the hull may mean breakup in the water column. A line of coal may reveal the path of a ship sliding downslope. A cluster of shells may show where a magazine opened. A field of containers may indicate a cargo hold that burst before impact. A propeller standing proud of the sediment may show how the stern settled. The ocean does not narrate the sinking, but it arranges the evidence according to forces that can be studied. There is another category of wreck that sits beyond reach because it has not yet been found. These are the absences on the map. A ship known to have vanished in deep water may occupy an area too large to search easily. Historical coordinates may be vague. The seafloor may be rugged. Search funds may be unavailable. Weather windows may be short. The wreck exists somewhere, but for now it remains only a sentence in records and a possibility in dark water. For families, nations, or communities connected to such vessels, discovery can matter even without recovery. A confirmed site changes the shape of loss. It moves the story from uncertainty to location. It allows memorial, legal protection. and sometimes a better understanding of final moments. But discovery can also reopen grief, especially when cameras show personal objects or spaces where people died. The ability to see must be matched by the discipline not to exploit. The title "Shipwrecks Lost Beyond Human Reach" could imply that the ships are unreachable because they are distant from land. But distance from land is only one kind of remoteness. A wreck may lie close to shore and still be unreachable if it has slid into a trench or canyon. Another may lie far offshore, but in manageable depth for specialized vehicles. Reach is not measured only horizontally. It is measured vertically, legally, ethically, technically, and emotionally. The vertical distance is the most visible. Every 10 meters adds pressure. Every 100 meters adds another layer of procedure. Every 1,000 meters changes what light, temperature, and access mean. At 6,000 meters, the surface is not simply above. It is another world with ships, weather, voices, satellites, and air. The wreck rests beneath all of it, in water that makes the surface feel like a rumor, yet the surface continues to feed the bottom. Marine snow falls from the productive upper ocean, carrying carbon and nitrogen into darkness. Dead fish, squid, jellyfish, salps, fecal pellets, and fragments of plankton descend. Large carcasses sometimes reach the seafloor and create temporary feasts. A shipwreck at depth is connected to sunlight indirectly, through the fall of material made in the lighted ocean above. This connection makes the wreck part of a larger vertical system. During the night, animals migrate upward to feed in shallower water, then descend by day. Their waste and bodies move carbon downward. Predators follow them. Some particles pass the wreck and settle nearby. A ship that once moved horizontally across the sea becomes part of the ocean's vertical traffic. The wreck can also interrupt that traffic. A piece of rigging or railing can catch drifting material. A collapsed deck can trap sediment. A vertical wall can alter local flow and particle deposition. These small changes can create patches of enrichment around a site. In the deep sea, where food is limited, even small changes in particle capture can matter to microbes and small invertebrates. Human objects can therefore become tools for studying the deep carbon cycle in a very narrow local sense. They show how material accumulates, how microbes respond, how animals use structure, and how disturbance creates new chemical and physical gradients. A wreck is not only something that fell from history, it is something that catches the falling remains of the living surface ocean. This may be one of the quietest ways to understand deep shipwrecks. The surface story is often sudden: collision, torpedo, storm, fire, ice, battle. The deep story is slow, particle by particle, cell by cell, animal by animal, layer by layer. A ship can be lost in a night and then spend centuries being received. The receiving is not gentle in the sentimental sense. It includes corrosion, consumption, burial, collapse, and contamination. It includes scavengers entering spaces where people once lived. It includes bacteria dissolving iron. It includes animals attaching to memorial surfaces. The ocean's acceptance is not comfort, it is process. But process is not the same as erasure. Many wrecks remain legible because deep time works differently at the scale of centuries. A name may survive. A hull number may survive. A cargo pattern may survive. A distinctive engine may survive. Even when the structure collapses, its distribution can remain readable. The wreck changes, but change does not always mean immediate disappearance. In this way, the deep sea is both archive and editor. It keeps some features and removes others. It preserves hard materials and consumes soft ones. It hides details under sediment and exposes others to current. It can protect a wreck from looting while destroying it chemically. It does not preserve the past for our benefit. It preserves or erases according to conditions. The more we learn about these sites, the less useful it becomes to speak of the deep ocean as simply untouched. It contains human debris, cables, munitions, wrecks, mining prospects, fishing gear, microplastics, and chemical traces. Some are recent, some are historic, some are protected, some are harmful. The deep sea is remote, but not separate from human history. Shipwrecks make that connection visible because they are large, named, and narratively powerful. A plastic fragment on the abyssal plain may be ecologically important, but a ship's bow gives people a shape their minds can hold. Once they understand that shape as part of the deep sea, they may begin to understand the smaller human traces as well. The wreck is a doorway into recognizing that the hidden ocean has never been completely outside us. Still, the deep sea remains its own world. It does not become human because human objects are present. The pressure does not change. The darkness does not lift. The animals do not become symbols unless we force them to. A shrimp on a wreck is not a metaphor. It is a shrimp on a surface, living in the conditions available to it. That restraint is important. It keeps the account honest. We can speak of loss, memory, depth, and mystery, but the deep sea animals must remain animals, not decorations for human emotion. They are not guarding the wreck. They are not mourning it. They are not haunting it. They are feeding, settling, sensing, hiding, and surviving. The wreck, in turn, is not a ghost in any biological sense. It is matter in water. It is steel, wood, glass, ceramic, copper, fuel, paint, sediment, microbial film, and animal life. The ghost belongs to human memory. The habitat belongs to the sea. The modern discovery of deep wrecks begins long before the first image. It begins with probability. Search teams gather last known positions, distress signals, survivor accounts, battle records, currents, weather, depth charts, and seafloor maps. They estimate where a vessel might have been when it lost buoyancy, how it might have drifted, and where the bottom lies beneath that uncertainty. This work can be less cinematic than the dive, but without it, the dive has nowhere to go. The ocean is too large for wandering. A ship can be over 100 meters long and still vanish inside the scale of a search box. At 4,000 meters, a camera sees only a narrow strip of bottom. At 6,000 meters, each pass is expensive in time and risk. Sonar gives the search its first broad vision. It turns darkness into acoustic texture, mapping slopes, scarps, mounds, debris shadows, and straight edges that may indicate something human-made. Side-scan sonar can show shadows. Multi-beam sonar can build bathymetry. Sub-bottom profilers may reveal buried features. Magnetometers can detect ferrous metal. Autonomous vehicles can fly search patterns close to the bottom, collecting data without a tether, while ROVs provide direct visual inspection. Each tool sees a different version of the seafloor. None sees everything. A sonar contact can be deceptive. A rock outcrop can look like wreckage. A wreck can look like geology if it is broken or buried. A trawl scar can create straight lines. A debris field can be too scattered to produce a clear target. Discovery requires suspicion, but confirmation requires evidence. The ocean produces many shapes, and not every straight-looking shadow is a ship. When a target is promising, the visual dive begins. The vehicle descends through water that may be empty to the human eye, but full of particles, plankton, and small animals. Pilots watch altitude, depth, heading, tether tension, and sonar returns. Scientists watch for the bottom. Historians watch for recognizable features. Everyone is waiting for the moment when data becomes material. The first view is often partial. A plate, a cable, a pipe, a riveted surface, a wheel half buried. The mind wants to assemble the ship instantly, but the vehicle has to move slowly. Sediment can blind the cameras if stirred. A fragile feature can break if touched. The scale is uncertain. The wreck may be enormous, but the vehicle is still moving through it one angle at a time. Lighting is one of the great compromises. Without light, there is no image. With too little light, the footage is dim and ambiguous. With too much light, particles reflect back and create a storm of white flecks. Strong lights can also alter animal behavior, drawing some animals closer and pushing others away. Every image of the deep sea is an artificial image because the light that makes it visible was brought there by us. This does not make the image false. It makes it specific. The wreck, as seen by NOAA, is the wreck under white artificial light from a particular angle, at a particular time, in a limited field of view. Its colors may not be the colors a deep animal perceives. Its shadows are created by the vehicle. Its apparent emptiness may reflect the moment of filming. Deep-sea vision is always an encounter between environment and instrument. Photogrammetry tries to overcome some of this limitation by gathering many overlapping images and turning them into a three-dimensional model. The process requires careful navigation, consistent coverage, scale, and enough visual texture for software to match points between photographs. In deep water, this is hard because the vehicle moves, currents interfere, lighting changes, and sediment or marine snow can obscure features. A clean model is not simply a camera product. It is the result of piloting, planning, processing, and interpretation. The value of such models is enormous. They allow researchers to measure features without returning immediately. They preserve the arrangement of a site at a given time. They let archaeologists compare future collapse, corrosion, or sediment movement against a baseline. They allow public access without physical disturbance. A wreck can remain in darkness while its digital form becomes a kind of remote museum. But digital preservation has limits. A model is not the site. It cannot capture every chemical gradient, every microbial community, every animal that moved away before the lights arrived, or every fragile object hidden under sediment. It represents the visible surface under survey conditions. The danger is thinking that once a wreck has been modeled, it has been fully known. A map is not the territory, and a model is not the deep sea. Sampling adds another layer of responsibility. A corrosion sample, a sediment core, a biological specimen, or a water sample can answer questions that images cannot. But sampling removes or disturbs something. On a protected wreck or war grave, the threshold for contact must be high. The ability of a manipulator arm to take does not mean taking is justified. Sometimes non-contact measurement is enough. Laser scales can show size. Visual inspection can record condition. Water sensors can measure temperature, salinity, oxygen, turbidity, and sometimes chemical anomalies. Current meters can help explain colonization patterns. Good exploration does not always mean bringing pieces back. Often it means leaving with better data. The control room on the research vessel is a strange human space. It is full of screens, cables, dim light, murmured instructions, and people watching a world none of them can physically enter. The ship may be rolling in waves, but on the screen, the bottom appears still. A pilot moves a joystick, and thousands of meters below, a machine shifts beside a wreck that has not seen sunlight since it sank. This separation can create emotional distance and intensity at the same time. No one is wet. No one feels pressure. Coffee cups may sit beside navigation displays, yet the images are coming from a place so hostile to the human body that a single failure in the vehicle can mean permanent loss of the machine. The ordinary and the extreme share the same room. For crude submersibles, the experience is more direct but still mediated. The people inside descend with the vehicle, watching the light fade through a viewport, feeling the duration of the descent in their bodies. They may reach the bottom and see the wreck without a screen between eye and object, but they are still inside a machine, sealed away from the water by engineering. The deep sea is close enough to see and still completely inaccessible to touch. Navigation at depth is itself a challenge. GPS does not work underwater. Vehicles rely on acoustic positioning, inertial systems, Doppler velocity logs, depth sensors, and references to the seafloor. In rugged terrain or near large metal structures, signals can be complicated. Knowing where the vehicle is, where the wreck is, and where the tether is can be as important as the camera view. Tethers are lifelines and hazards. They carry power and data for many ROVs, but they can snag on wreckage, drag across fragile features, or limit movement around complex structures. Pilots must think not only about where the vehicle is going, but also about the path of the line behind it. A wreck is three-dimensional, and the tether remembers every turn. Autonomous vehicles avoid tether problems, but bring other risks. They operate according to programmed missions and onboard decision-making, which is useful for broad search, but less flexible for delicate close inspection. If something goes wrong, communication is limited until the vehicle surfaces or is recovered. Under ice, the risk becomes more serious because surfacing is not simple. Every access method solves one problem and creates another. This is why deep wreck exploration remains rare. It requires money, equipment, ships, weather windows, permits, expertise, and a reason strong enough to justify the effort. Many known wrecks will not be visited often. Some may be seen once and then left unvisited for decades. The deep sea does not only hide wrecks before discovery, it keeps them difficult afterward. Public footage can make exploration seem smoother than it is. Edited video removes hours of descent, searching, repositioning, navigation checks, blank seafloor, and technical conversation. People see the reveal, the recognizable feature, the haunting passage over the bow. But most deep ocean work is patience, and patience rarely survives intact in a highlight reel. For a subject like this, it is worth keeping that patience. The ship is not found because the ocean decides to show it. It is found because people compare records, build equipment, map terrain, test systems, wait for weather, descend slowly, and accept that the first dive may fail. Discovery is often less like opening a door and more like reducing uncertainty one layer at a time. The technology also changes what questions can be asked. Early expeditions asked, "Is it there, and what does it look like?" Later expeditions ask, "How has it changed? What communities live on it? How fast is it corroding? What risks does it pose? How is the sediment chemistry altered? And how can it be protected without removing it?" Better cameras do not only make better pictures, they create better questions. There is a danger in treating technology as conquest. A vehicle that reaches a wreck at 7,000 meters is an extraordinary achievement, but the dive does not defeat the deep sea. It survives briefly inside it. The pressure remains, the darkness remains, the limits remain. Exploration is not domination. It is temporary permission granted by engineering and conditions. When the vehicle leaves, the wreck returns to darkness. The lights rise away, sediment settles. Animals resume whatever the lights interrupted. The research vessel retrieves its machine and turns data into maps, images, reports, and sometimes documentaries. The ship below does not know it has been discovered. Discovery happens at the surface. That may be the most humbling part. Human beings can search for a century, build a machine, descend through miles of water, and finally see a wreck. For the deep sea, nothing has arrived except a temporary light. The wreck was already there. The animals were already using it. The corrosion was already working. We are not bringing the ship into existence. We are catching up to a reality that continued without us. The place where a ship lands can matter as much as the ship itself. A wreck on a continental slope is not living the same afterlife as a wreck on an abyssal plain. Slopes can carry stronger currents, sediment movement, and connections to productive shallow water. Submarine canyons can funnel organic matter downward like hidden river valleys, delivering particles, carcasses, and disturbed sediment into deeper basins. A wreck placed in such a canyon may experience more burial, more exposure, and more food delivery than the same wreck on a quiet plain. Canyons are not just geological cuts. They are habitats with walls, ledges, current accelerations, sediment flows, and biological communities that can differ sharply over short distances. Deep corals may grow on exposed canyon walls where currents bring food. Fish may use the relief. Crustaceans may follow organic material moving downslope. If a ship falls into such a system, it becomes one more piece of vertical complexity in a place already shaped by motion. On an abyssal plain, the wreck may appear more isolated. The seafloor can stretch outward in pale sediment with few hard surfaces visible. Tracks of animals may cross the mud. Holothurians may move slowly across it. Brittle stars may rest partly buried. A sudden steel structure in that setting is dramatic, not because it is frightening, but because it is geometrically out of place. Straight edges do not belong easily to mud that has been settling particle by particle for ages. The abyssal plain also emphasizes food scarcity. Most of the energy arriving there has traveled a long way from the surface. It has been eaten, repackaged, dissolved, fragmented, and slowed. By the time marine snow reaches the bottom, it is the remains of remains. A wreck on the abyssal plain may provide shelter and surface, but it does not change the basic fact that food is limited and life must be efficient. Near a seamount, the story changes again. Seamounts rise into currents, and currents can concentrate plankton, particles, fish, and predators. Hard rock provides natural attachment points for corals and sponges. A wreck on or near a seamount may enter a more naturally structured environment where hard substrate is not as rare as it is on soft plains. In that case, the wreck may be less an island and more an added neighborhood beside an older city of stone. At cold seeps, chemicals from beneath the seabed support communities that do not depend entirely on falling surface food. Methane and sulfide can fuel microbial production, which in turn supports mussels, clams, tube worms, and other animals in certain regions. If a wreck lies near seep activity, it may be influenced by a seafloor already chemically rich. It would be wrong to say the wreck creates the seep community, but it may add structure to a place where chemistry is already shaping life. Hydrothermal vents are more extreme still, though wrecks are not commonly central to vent ecology. Vent fields are built around hot, chemically rich fluids rising from the crust, supporting dense communities of specialized animals. A shipwreck near such a system would meet a seafloor where life is organized around chemical energy, temperature gradients, and mineral deposition. It reminds us that the deep sea is not one environment. It is a collection of worlds stacked and spread through darkness. Oxygen also matters. Some ocean regions contain oxygen minimum zones, where midwater oxygen is low enough to shape animal distribution and behavior. A wreck passing through such water during descent and resting beneath or within related conditions may enter a system where oxygen availability limits which animals can remain active. Oxygen is not a background detail. It is one of the invisible boundaries that decides where life can function. Temperature is another boundary. Near freezing deep water slows many chemical and biological processes, but animals adapted to it live normally there. In warmer deep basins, decay may proceed differently. In polar waters, cold can preserve some materials while also limiting biological attack by certain organisms. The deep ocean is cold in much of the world, but cold is not uniform, and its effects depend on what else is present. Sediment type changes the wreck's future. Fine mud can bury fragile objects and protect them from some forms of exposure while hiding them from cameras. Coarser sediment can leave objects more exposed. Slumps can cover a wreck suddenly. Bottom currents can scour around heavy features, creating moats or exposing lower hull sections. A wreck is partly excavated or buried by water that may move too slowly for the camera to notice in real time. Burial can preserve and erase at once. An object under sediment may avoid some corrosion or biological attack, but it also becomes invisible. Archaeologists may see only the highest features and have to infer the rest. Disturbing sediment to reveal more can damage the protective environment that kept the object intact. Sometimes not seeing everything is part of preserving what remains. The water column above the wreck remains active even after the ship comes to rest. Animals migrate through it daily. Squid hunt in darkness. Fish form scattering layers. Gelatinous animals drift and pulse. Bioluminescent flashes occur beyond the camera, mostly unseen unless a sensor or dark-adapted eye catches them. The wreck sits on the bottom, but the ocean above it is moving with life. This vertical life affects the wreck through falling material. A dead salt may sink. A squid beak may reach the sediment. Fecal pellets descend from feeding layers. Plankton blooms at the surface eventually send particles downward. Storms can change export from the upper ocean. Seasonal productivity can alter the amount of food reaching depth. The wreck's community is therefore connected to weather and sunlight it never directly experiences. The connection can be hard to imagine because the deep wreck looks detached. It sits in darkness, under pressure, far from shore. But every particle crossing the lights came from somewhere. It may be mineral sediment, dead plankton, mucus, fecal material, tiny shells, or fragments of animals. Marine snow is the surface world arriving in pieces. For animals on the wreck, this fall can be food. Suspension feeders capture particles from water. Deposit feeders consume enriched sediment. Scavengers respond to larger falls. Microbes process what others cannot use. A wreck can catch and hold some of this material, making local patches richer than open mud nearby. The ship is not only a structure in the deep sea, it is a trap in the rain. Bioluminescence changes the way animals use the surrounding darkness, though the wreck itself does not glow unless colonized by organisms that produce light or passed by animals that do. In the water column, light can lure prey, confuse predators, signal mates, startle attackers, or camouflage silhouettes through counter-illumination. A sinking ship would have passed through a world where many animals make their own brief light, but once it rests on the bottom, its visibility mostly depends on the lights we bring. That imported light can briefly turn a wreck into a stage. Animals that normally live in darkness are illuminated against human history. A fish beside a gun. A crab on a deck. An anemone on a nameplate. These images feel symbolic because our minds make them symbolic. The animals are not performing. The light has simply made their ordinary presence visible. When the lights leave, the wreck does not disappear for the animals that use chemical cues, touch, current, vibration, or memory of place. It disappears for us. This is important. Human visual access is not the same as existence. The deep sea continues in darkness with or without an audience. In some habitats, natural hard substrate may be rare enough that a wreck becomes a major feature. In others, surrounded by rock, coral mounds, or carbonate outcrops, it is only one surface among many. The biological response must be interpreted locally. A wreck covered in life in one region does not prove all wrecks are ecological treasures. A barren-looking wreck in another region does not prove it is unimportant. The surrounding landscape also shapes preservation. A wreck on a steep slope may be unstable. A wreck near active sediment transport may be buried and exposed repeatedly. A wreck in very quiet deep water may retain delicate features longer. A wreck in corrosive water or with strong microbial activity may lose metal faster. The ship's future is written by environment as much as by construction. This is why the same material can tell different stories. Steel from one wreck forms rusticles. Steel from another remains as heavy plates with less visible growth. Wood in one sea vanishes quickly. Wood in another remains legible for centuries. Ceramic cargo may remain almost unchanged. Glass may survive with little alteration. The ocean is not one force. It is many conditions acting through one body of water. This complexity is easy to miss because footage often centers the wreck and darkens everything else. But the water, sediment, slope, current, oxygen, temperature, and animal community are not background. They are the reason the wreck looks the way it does. The ship is the visible subject. The habitat is the author of its afterlife. A deep sea channel has to keep returning to that habitat. Otherwise, a shipwreck story becomes only human drama placed in black water. The more accurate story is stranger and more grounded. A human drama falls into an ecosystem. The ecosystem does not stop being itself. It receives the wreck according to its own rules. Every wreck is also a source of decay. The word decay can sound natural, but on a ship it includes many processes that were never part of the deep sea before the hull arrived. Iron oxidizes. Paint flakes. Rubber hardens and breaks. Plastics persist. Fuel residues seep or remain trapped. Ammunition casings corrode. Batteries, wiring, insulation, and cargo materials weather in their own ways. The wreck does not dissolve into a single harmless memory. It enters the environment as a collection of substances. For older wooden sailing vessels, the material concerns may be different. Timber, ballast, iron fastenings, copper sheathing, ceramics, glass, lead, cargo, and organic remains. For 20th century wrecks, especially from wartime, the concerns can include fuel oil, explosives, heavy metals, and synthetic materials. Age does not automatically make a wreck benign. A recent wreck can be dangerous, but an old wreck can also contain persistent materials. Fuel is one of the most visible risks when it leaks, but deep leaks are not always visible to people. Oil can remain in tanks for decades if compartments stay sealed, then escape as corrosion opens pathways. Sometimes oil seeps slowly. Sometimes a disturbance or collapse releases more. The deeper the wreck, the harder the response. There is no simple shoreline cleanup at 4,000 meters. Microbes may consume some hydrocarbons, and natural seep environments show that the ocean contains organisms capable of using oil and gas compounds. But microbial degradation does not make every leak harmless. Rates vary with temperature, oxygen, composition, and dispersion. Oil can affect animals before it is fully broken down. The presence of oil-eating microbes is not permission to ignore pollution. Munitions add another problem. Shells, torpedoes, depth charges, and ammunition may remain on or within wrecks. Corrosion can expose explosive material or toxic compounds. Disturbance can be dangerous to equipment and people, and environmental effects can be difficult to assess. A war wreck may look still and silent, but some of its cargo was designed not to be harmless. Because of this, deep wreck management often requires more than heritage protection. It may involve environmental monitoring, risk assessment, legal responsibility, and sometimes intervention. But intervention itself can damage a site. Removing oil from a deep wreck may reduce pollution risk, but require drilling, pumping, or contact with fragile structure. There is no perfect choice, only choices weighed against time, risk, and consequence. The slow collapse of a wreck can change those risks. A tank that is sealed today may open later. A deck that supports sediment and animals may fall into a compartment. A hull plate may peel away. Corrosion can create sudden failures after long periods of apparent stability. Deep time at the scale of a human life can still contain abrupt moments. This is why repeat surveys matter. A wreck filmed once is not fully understood. Images from different years can show changes in railings, holes, collapse, biological cover, sediment movement, and leakage. Baseline documentation allows scientists to distinguish gradual deterioration from sudden disturbance. To protect a deep wreck, first you have to know how it is changing. But monitoring every wreck is impossible. There are too many sites, too much ocean, too little ship time, and too few specialized vehicles. Managers must prioritize war graves, pollution risks, highly significant heritage sites, wrecks in areas of human activity, and sites that can answer important scientific questions. The hidden ocean is too large for complete surveillance. That incomplete surveillance leaves many wrecks to the ocean's private processes. They corrode without being recorded. They host animals without being studied. They collapse without anyone seeing the before and after. The fact that a wreck is unknown does not make it inactive. It only means its changes are not entering human records. There is humility in that. We often speak as if discovery begins the real existence of a wreck, but the wreck may have been changing for a century before the first camera arrived. Animals may have lived and died there for generations. Microbial communities may have passed through stages of succession. Sediment may have buried and exposed features repeatedly. The human record starts late. This lateness should shape the narrator's attitude. We are not revealing a place that was waiting in perfect stillness. We are joining a process already underway. That process includes history, but it is not controlled by history. The ship's name may bring us to the site, but the site has been living and decaying without needing the name. Some people may want a wreck raised. The desire is understandable when the object is famous or emotionally important. Bringing something up feels like rescue. But deep wrecks are often fragile, integrated with sediment and life, and protected as graves or heritage sites. Raising them can destroy context and accelerate decay once materials meet air after long submersion. Recovery is not always preservation. Sometimes the most destructive thing you can do to a wreck is save it badly. Artifacts removed from deep water require conservation. Salt, corrosion products, waterlogged wood, unstable metals, and organic materials can deteriorate rapidly if not treated. Conservation can take years and enormous resources. Without it, recovery may turn an artifact into a ruin. The museum object begins its second danger the moment it leaves the sea. Leaving artifacts in place also preserves relationships between objects. A cup near a doorway, a tool beside machinery, a shell casing at a gun, a cargo item within a hold, all carry meaning from position. Remove them, and the site loses grammar. Archaeology is not only what an object is, it is where it is, what it lies beside, and how it became part of a pattern. Deep sea biology adds another reason for restraint. A recovered object may carry living organisms or communities that are poorly known. Removing it removes habitat. It can also bring deep organisms into conditions they cannot survive. A coral on a railing is not an accessory to the artifact. It is a life attached to a surface it has made its own. At the same time, there are cases where limited recovery or sampling is justified. A diagnostic artifact may identify a wreck. A corrosion sample may help manage pollution risk. A biological specimen may answer a scientific question that imagery cannot. But justification has to be specific. In the deep sea, the default should not be taking. The default should be asking what knowledge requires and what respect allows. The legal status of underwater cultural heritage has developed partly in response to these problems. International principles increasingly favor in situ preservation, non-destructive methods, and protection from commercial exploitation. Not every nation has the same laws, and enforcement at sea is difficult. But the ethical direction is clear. The deeper technology reaches, the more important it becomes to decide that not everything reachable should be taken. War graves carry a particular weight. A wreck where people died is not simply a historic resource. It is a burial place in the broadest sense, even if bodies are no longer visible or preserved. Families may never have had a physical grave. The wreck is the closest thing to one. A camera can visit such a place, but it should do so with the knowledge that absence is not emptiness. The animals living there do not diminish that status. They make the site more complex. A grave can become habitat. A habitat can contain human remains. The categories overlap because the ocean does not separate them for us. Human ethics must operate inside ecological reality, not in denial of it. Environmental change may alter the future of deep wrecks. Ocean warming, deoxygenation, acidification, changes in currents, and shifts in surface productivity can affect corrosion, biological communities, and the amount of food reaching the bottom. The deep ocean changes slowly in some ways, but it is not isolated from climate. Conditions around a wreck in the future may not match the conditions that preserved it in the past. Increased human use of the deep sea adds more pressure. deep-sea mining interest, expanding cable networks, energy infrastructure, and more capable private exploration all increase the chance that remote sites will be encountered or disturbed. Fishing gear already reaches many deep slopes and seamounts, and bottom contact can damage both natural habitats and wreck sites. The deep sea is becoming more accessible before it is fully understood. This creates a responsibility for storytelling. A public account of deep wrecks should not simply turn them into spectacle. It should help people understand why distance matters, why context matters, why the animals matter, and why the wreck should often remain where it is. Wonder without restraint becomes consumption. Curiosity with restraint becomes attention. Attention is slower. It notices the rust, but also the bacteria. It notices the gun, but also the anemone. It notices the depth record, but also the pressure that made the record meaningful. It notices the name of the ship, but also the unnamed animals passing over it. The deep sea rewards attention more than excitement. And attention changes what the phrase "lost" means. A wreck may be lost to its owners, lost to the surface, lost to ordinary access, and still not lost to the ocean. It has a location, a chemistry, a community, a rate of change. It is lost from one world and received by another. There are wrecks that have been searched for and not found, and those absences can be as revealing as discoveries. A search may cover a carefully chosen grid and return only geology. It may find debris that belongs to another vessel. It may locate a scatter too damaged to identify. It may discover that the historical position was wrong by miles. Failure in deep water is not always failure of effort. Often it is the ocean reminding us that uncertainty has scale. The seafloor does not make itself convenient for history. A ship may rest under sediment. It may have broken into pieces too small to stand out on sonar. It may lie on rugged volcanic terrain where shadows confuse interpretation. It may be covered by a landslide or lost among natural boulders. The absence of a clear target does not prove absence of the wreck. It proves only that the methods used have not yet found a recognizable signal. This is especially true for older wrecks. Wooden ships can vanish almost completely in many environments, leaving ballast, anchors, cannons, ceramics, or cargo as the main evidence. Without a nameplate or bell, identification may depend on cargo type, construction details, dating, and historical route analysis. A wreck can be present as a pattern long after the ship shape is gone. For ancient trade, those patterns can be extraordinary. Amphora fields in deep water can reveal routes, commodities, and economic connections across centuries. The wood may be gone, but the cargo records the vessel's purpose. A scatter of jars on a slope may show where a ship broke apart, how it settled, and what it carried from one port to another. The deep sea can preserve commerce as geometry. A modern steel vessel usually leaves more obvious traces, but even steel can become ambiguous. A trawler, freighter, tanker, or warship may be reduced to collapsed plating, machinery, and debris. If the ship carried a common design, identification may require a specific feature. Many ships were not unique in form. The deep sea may preserve the class before it preserves the name. Names matter to people. They connect a wreck to stories, families, nations, insurance records, cargo manifests, and loss lists. But the ocean does not need the name to continue its work. A named wreck and an unnamed wreck corrode at the same rate if their materials and conditions are the same. This can feel harsh, but it is also freeing for the science. An unknown wreck can still teach us about habitat, corrosion, and deep-sea processes. It can still support life. It can still require protection if it is culturally significant or environmentally risky. Identification adds human context. It does not create ecological importance from nothing. The unknown also prevents the account from becoming too certain. Deep sea stories should leave room for what has not been seen. Even famous wrecks have hidden sections, unvisited debris, buried features, and poorly understood biological processes. Many less famous wrecks have no footage at all. The deep sea is not mysterious because we know nothing. It is mysterious because what we know is surrounded by an enormous amount we have not yet observed. There are also wrecks that may never be visited for good reasons. Their locations may be protected. Their disturbance may be too risky. Their depth may make repeated access unjustifiable. Their cultural significance may call for silence rather than exposure. Not every site needs to become an image for public consumption. This idea can be difficult in a visual culture. A wreck feels real when seen. Footage gives shape to memory. But respecting a site may mean accepting incomplete visibility. It may mean using remote sensing without close approach, or documenting only enough to confirm and protect. The deep sea does not owe us every room. When a camera enters a wreck, the ethical stakes rise. Interior spaces are more fragile, more likely to contain trapped sediment, personal objects, and remains. Thrusters can stir clouds that reduce visibility and settle on delicate surfaces. A tether can snag. A vehicle can become trapped. The desire to go inside must be weighed against the possibility of damaging what has survived. Interiors also change the feeling of a wreck. Outside, the ship can be terrain. Inside, it becomes architecture again. Doorways, corridors, machinery spaces, cabins, and stairways reintroduce the human body as the measure. A passage is wide enough for a person. A bunk is sized for sleep. A galley is arranged for work. The deep sea enters these spaces slowly, but once the camera follows it, the human scale becomes clear how recently human they were. Animals use interiors too. Fish may shelter in openings. Crustaceans may move through pipes. Sediment may gather on floors. Bacteria grow on surfaces. An octopus may use a cavity if conditions allow. A room does not remain a room simply because humans recognize it. In the deep sea, it becomes an enclosed habitat with human proportions. The transformation can be unsettling because it turns ordinary spaces into ecological niches. A wheelhouse becomes a shaded void. A cargo hold becomes a sediment trap. A ventilation duct becomes a passage for small animals. A porthole becomes an opening between darkness and darker interior. The ship's design continues to shape movement even after the purpose of that design is gone. This is true of small objects as well. A bottle can trap sediment or provide shelter for a small animal. A coil of cable can collect particles. A crate can create a crevice. A shoe can become a surface for microbes before it disappears. The scale of human use becomes the scale of deep-sea opportunity. But some objects should not be lingered on too heavily. Personal effects can turn tragedy into spectacle if treated carelessly. A careful account should not reach for emotion by pointing at every intimate remnant. Restraint means allowing the object to be seen without forcing it to perform grief. The strongest approach stays mostly direct. It gives facts room to carry weight. It does not need every sentence to tremble. Deep wrecks are already powerful. The pressure, distance, loss, and living ocean are enough. The human account should not compete with the seafloor. There is also a difference between mystery and vagueness. A deep wreck can be mysterious because its breakup sequence is uncertain, its biology is still being studied, or its location is unknown. But it should not be made mysterious by ignoring what is known. Honest mystery begins where evidence ends, not where explanation becomes inconvenient. For example, it is fair to say that direct observations of many deep wreck communities are rare. It is fair to say that microbial processes are complex and site-specific. It is fair to say that some wrecks may influence biodiversity in nearby sediments. It is not fair to say that the deep sea has no rules, or that wrecks become supernatural monuments outside biology. The deep sea is difficult to know, but it is not lawless. The same caution applies to animals. A hagfish feeding on remains is not a horror creature. It is a scavenger performing an ecological role. A grenadier circling a wreck is not a guardian. It is a fish investigating or foraging. An anemone on a rail is not a flower for the dead. It is a cnidarian feeding in current. The real animals are more interesting when we let them remain real. When a dead whale reaches the seafloor, it can support a dense community because the body carries enormous energy. A shipwreck may support life differently because it offers structure more than calories after the initial organic pulse is gone. This distinction matters. Not every island on the deep seafloor is an island of food. Some are islands of surface, relief, shelter, chemistry, or disturbance. In many cases, the first organic pulse after a sinking would have been temporary. Food stores, bodies, paper, leather, wood, cloth, and other organic materials may attract scavengers and microbes. Over time, much of that material is consumed or buried, leaving longer-lasting steel, ceramics, glass, and other resistant materials. The wreck's early afterlife may have been far more biologically intense than the quiet images taken decades later. This early phase is usually unobserved. Few wrecks are filmed immediately after sinking at great depth. Scientists often arrive decades later, after the first scavenging, collapse, and colonization have already occurred. We study the aftermath of the aftermath. That delay shapes every interpretation. If a wreck from 1944 is first filmed in 2022, the camera is not seeing the beginning. It is seeing a site after nearly 80 years of deep-sea processing. If Titanic is filmed more than a century after sinking, the rusticles, collapse, and communities represent long development. A deep wreck image is always a time slice. The time slice can still be rich. It can show what survived, what failed, what settled, what colonized, and what changed since earlier surveys. It can provide enough evidence to model the wreck, protect it, or understand its ecological role. The fact that the first chapters are missing does not make the later chapters meaningless. Future technologies may recover some missing context. Better autonomous vehicles may map larger areas. Environmental data may reveal animals that cameras miss. Chemical sensors may detect seepage or microbial activity. Machine learning may help identify sonar targets or compare images over time. The next stage of deep wreck exploration may be less about a single heroic dive and more about sustained, careful monitoring. Environmental data is especially intriguing because water and sediment can carry genetic traces of organisms that passed through or lived nearby. Around a wreck, such sampling might reveal communities not visible during a short dive. It could help distinguish occasional visitors from established residents. But data is also evidence that must be interpreted cautiously, because currents move traces and detection does not always prove behavior. Long-term observatories could change the picture even more. A camera or sensor package placed near a wreck, if allowed and designed responsibly, could record daily, seasonal, or episodic changes, scavenger visits, sediment movement, leakage, oxygen shifts, or animal behavior when human lights are absent. The deep wreck would stop being a single scene and become a place with rhythms. Such monitoring raises its own concerns. Instruments can disturb sites, attract animals, fail, or become debris. Batteries, anchors, cables, and frames must be managed. The desire for data must be weighed against the integrity of the wreck and habitat. Even observation has a footprint. The best future may involve a mix of approaches: broad mapping from above, limited visual survey, non-contact measurement, carefully justified sampling, digital modeling, legal protection, and public storytelling that does not encourage looting or reckless visitation. A deep wreck can be shared without being consumed. Public storytelling matters because most people will never read a technical report. They will understand these places through images, museum exhibits, articles, and documentaries. If those stories focus only on treasure or fear, they train the audience to value the wrong things. If they include habitat, uncertainty, and restraint, they create a more accurate form of wonder. wonder can be educated. That educated wonder is important for the deep sea as a whole. Shipwrecks are only one form of human presence, but they are visible enough to make the hidden ocean feel connected to human decisions. A wreck shows that what happens at the surface does not stay there. Some of it sinks, and the deep sea has to live with it. There is a final category of deep wreck that is not defined by fame, depth record, preservation, or biology alone, but by the way it changes our sense of the ocean's scale. These are the wrecks whose stories can be told at the surface in a few minutes, but whose resting places require hours of descent. A storm, a battle, a collision, a loss of power, a mistake in navigation, a pressure wave from an explosion. The cause may be brief. The vertical consequence is immense. A ship can leave the surface world quickly. It can vanish from sight while people are still watching. But after it disappears, it continues moving through layers of water that few witnesses ever imagine. It passes from noise into muffled darkness, from air into compression, from waves into cold stability, from human emergency into ocean process. At each layer, the ship becomes less like itself. The upper ocean strips away buoyant debris. The twilight water receives objects that sink at different speeds. The midnight zone removes the last ordinary visual context. The bottom converts the wreck into terrain. The ship's identity remains in records and materials, but its function is gone. It no longer carries. It no longer shelters people. It no longer moves intentionally. It only remains. Remaining is not passive. A wreck remaining in the deep sea is being acted upon constantly. Water presses. Currents test edges. Sediment gathers. Microbes alter surfaces. Animals investigate, settle, feed, and leave. Corrosion opens holes. Structures weaken. The deep sea is slow enough to seem still and active enough to make stillness an illusion. The wreck is often first encountered at a moment of artificial clarity. The beam is clean. The camera is stable. The feature is recognizable. The account can name the ship, the depth, the date of sinking, the expedition that found it, and the animals visible in frame. This can make the story feel complete. But the completeness is constructed. Outside the beam is the rest of the wreck, the rest of the site, and the rest of the ocean. This is why the subject asks for time. A short account can give the headline, a ship sank, a wreck was found. It lies at a certain depth. But the deep sea adds layers that need time. Pressure needs time. Corrosion needs time. Animal colonization needs time. Ethical questions need time. A shipwreck beyond human reach is not one reveal. It is a slow unfolding. The unfolding begins with the recognition that human reach has always depended on tools. Ships themselves were tools for extending reach across water. Navigation extended reach through uncertainty. Engines extended reach against wind. Radio extended reach across distance. Sonar, ROVs, and submersibles extend reach downward. A deep wreck is therefore both a failure of one technology and a target for another. But no tool removes vulnerability completely. The ship failed, or was overcome. The search vehicle can fail. The research vessel can be forced away by weather. The submersible can reach its limits. The camera can be blinded by silt. The model can be incomplete. Human reach is always conditional in the ocean. The animals do not reach in this way. They belong where they are. A hadal amphipod is not impressed by a depth record. A deep coral does not know it has settled on history. A microbial colony consuming iron does not know the name of the ship. Their lives make the wreck less lonely without making it less lost. This is one of the quiet truths of shipwrecks beyond reach. They are not waiting alone in darkness. They are accompanied by processes and organisms, but not by the kinds of companionship human stories often imagine. No one stands watch. No one keeps memory except people at the surface. The ocean keeps matter, not meaning. Meaning has to be carried down by us and brought back carefully. A careful descent does not demand that the deep sea become a theater of ghosts. It allows the wreck to be physical. It allows the ship to be damaged. It allows animals to be ordinary. It allows uncertainty to remain where evidence is incomplete. The truth is strong enough without invention. The truth includes numbers. Titanic at about 3,800 meters. Bismarck at nearly 4,800 meters. Endurance at just over 3,000 meters beneath the Weddell Sea. Johnston at about 6,456 meters. Samuel B. Roberts at about 6,895 meters. These numbers are not decorations. They are measures of separation. Each number also represents pressure. At Titanic's depth, the pressure is hundreds of times greater than at the surface. At the deepest wrecks off Samar, it is greater still, enough that only vehicles built for the most extreme parts of the ocean can operate there. Depth is not only distance, it is force. The truth includes darkness. Below 1,000 meters, sunlight does not penetrate in a way that can illuminate the world. The wrecks lie in water where their visibility depends on machines and living light. If no vehicle is present, the bow, the stern, the cargo, the animals, the rust, and the sediment are all held in darkness. They do not need to be seen in order to continue changing. The truth includes food scarcity. A wreck may gather life, but the life around it still depends on food arriving from somewhere, particles falling from above, prey moving through, organic material trapped by structure, or chemical energy in special habitats nearby. The deep sea is not empty, but it is economical. Nothing there can ignore energy. The truth includes uncertainty. Direct observations are rare. Many behaviors are inferred from brief footage. Microbial processes vary. Corrosion rates differ from site to site. Some wrecks are found, others remain missing. Some features are interpreted confidently, others remain ambiguous. Uncertainty is not a weakness in the story. It is one of the most honest parts of the story. The truth includes loss. Ships sank with people aboard. Communities waited for news. Families inherited absence. Wars scattered vessels into deep water. Trade routes left wreckage where storms and attacks found them. Exploration ambitions ended under ice. The deep sea holds human consequences as well as human objects. And the truth includes life. Not life as decoration, but life as persistence. Bacteria on iron. Anemones in current. Sponges on edges. Fish moving through beams. Crabs and shrimp using structure. Amphipods in Hadal sediments. Microbes altering the seabed near wreck material. The wreck is human in origin, but its afterlife is ecological. When these truths are held together, the deep wreck becomes more than a symbol. It becomes a place where engineering, disaster, oceanography, microbiology, archaeology, and animal life meet. It is not a haunted object or a simple reef. It is not only a grave or only a habitat. It is all of these things at once, and the difficulty is to speak of it without flattening it. The camera returns to the wreck one more time. It approaches slowly over sediment marked by small tracks. Marine snow moves through the lights. The first metal appears as a low shape, then a wall, then a curve that the mind recognizes before the account names it. A fish turns in the edge of the beam. For a moment, the ship is visible again. Then the camera rises slightly, and the wreck becomes landscape. The deck is no longer a deck in any useful way. It is a surface in current. The opening is no longer a doorway. It is a shelter and a shadow. The rail is no longer for hands. It is a line where animals can attach. Human design remains, but human use is gone. The vehicle keeps moving because it cannot stay forever. Power, schedule, weather, and risk all pull it back toward the ship above. The control room records the last pass. The pilots guide the vehicle away from fragile edges. The lights leave the hull. The wreck returns to the dark with no ceremony. Above, the research vessel may still be rolling in daylight. People may step outside and see waves, clouds, birds, and the horizon. It can feel impossible that a ship lies miles below, beneath the same water, surrounded by animals that have never known the surface as a place of air. The ocean connects those worlds without making them similar. This is the scale that deep shipwrecks reveal. Not only the scale of loss, or depth, or engineering, but the scale of separation between human experience and ocean reality. We build ships to cross the surface because the surface is the part of the ocean we can inhabit for a while. The deep remains different. When a ship sinks beyond reach, it crosses from the human layer into the ocean's larger body. There it will continue. Rust will thicken and fall. Wood will soften or endure depending on conditions. Sediment will gather. Some structures will collapse. Some objects will remain long after their purpose is forgotten. Animals will arrive and leave. Microbes will keep working. The wreck's future is not a single fate. It is a series of changes too slow for one life to watch completely. Perhaps centuries from now, another vehicle will pass over the same site. It may find less metal, more collapse, a different community, a changed sediment field, or only scattered remnants where a famous form once stood. It may compare its images with ours and see what time has done. The deep sea will have been writing between visits. That writing is the final narrator of every wreck. Human voices can describe, interpret, remember, and warn. Instruments can measure. Cameras can reveal. But the ocean continues after the human account ends. It does not close the story. It keeps revising the remains. So, when we look at shipwrecks lost beyond human reach, we are not only looking down at the ruins of surface history, we are looking at the point where that history becomes part of the deep ocean's living and chemical world. We are looking at the limit of the body, the extension of machines, the patience of corrosion, and the ordinary lives of animals in a place that feels extraordinary to us. The ship is lost, but the place is not empty. It is dark, cold, pressured, and far away. It is full of particles falling from the lighted sea. It is crossed by animals adapted to conditions that would destroy us. It holds structures that once carried people and now carry anemones, bacteria, sediment, and memory. Beyond human reach does not mean beyond the world. It means beyond the part of the world that was made for us. And that may be why these wrecks hold attention so deeply. They show us that human stories do not end at the surface, even when human presence does. They fall, settle, corrode, and become part of a realm where our meanings are carried only by the machines we send and the care we bring back. Down there, under miles of water, the ocean is still working. The lights leave. The animals remain. The ship stays where it fell, no longer sailing, no longer waiting, but slowly becoming seafloor. There is another reason these sites matter now. The number of deep ocean images is increasing. More vehicles can descend. More maps exist. More private expeditions, research programs, and national surveys are capable of finding what previous generations could only estimate. This does not mean the deep sea has become familiar. It means the boundary of visibility is moving, and every movement of that boundary brings responsibility with it. A newly visible wreck can be protected, studied, and respected, but it can also be publicized carelessly. Exact coordinates can invite interference. Dramatic editing can encourage people watching to see the site as an adventure prize. Object-focused storytelling can turn context into background. The first public story told about a wreck can shape how people think it should be treated. For this reason, the best deep-sea storytelling treats discovery as the beginning of care rather than the end of the search. It asks what the site is, what lives there, what risks it faces, who has a cultural connection to it, and what should not be disturbed. It shows enough to create understanding without making disturbance feel desirable. A wreck can be revealed and still remain protected. The animals are part of that protection, even when laws are written for heritage rather than ecology. If a wreck supports corals, sponges, anemones, fish, crustaceans, microbial communities, or sediment changes, then damaging the wreck also damages habitat. If a wreck leaks pollutants, protecting the site may require environmental action as well as archaeological restraint. The human and biological values cannot always be separated neatly. This is especially true where wrecks sit among vulnerable deep-sea habitats. Deep corals and sponges can be long-lived and slow-growing. A single physical impact can break structures that took decades or centuries to develop. If a wreck has become part of such a community, then salvage, careless sampling, or even poor piloting can have consequences beyond the artifact itself. The deep sea heals slowly, when it heals at all. The slow pace of recovery should change how we imagine damage. On land, a broken branch may regrow in a season. In the deep sea, a broken coral branch may represent decades. A disturbed sediment layer may remain visible for years. A lost instrument or snagged cable may sit as new debris in a place already carrying too much human material. The cost of a mistake is measured in deep time, not in the length of the dive. Yet fear of damage should not end exploration. Without observation, wrecks cannot be understood, protected, or monitored. The answer is not to look away from the deep sea, but to look with better methods and better motives. The deep ocean needs witnesses, but witnesses who know they are guests. A good witness notices the scale of the descent and the smallness of the animal. It notices the engineering of the ship and the engineering of the vehicle. It notices that a rusticle is not only decay, but community. It notices that a famous wreck and an unknown wreck both become part of the same physical world once they reach the bottom. It does not need to make the sea darker than it is. It is dark enough. The wrecks beyond reach also remind us that human history is not stored only in archives, museums, and monuments. Some of it is stored under pressure, under cold water, under sediment, under marine snow, and inside habitats we are only beginning to document. It is stored in places where the past cannot be separated from fish, microbes, currents, and corrosion. The archive is alive, or at least surrounded by life. That living archive asks for a different kind of imagination. Not the imagination that invents monsters, but the imagination that can hold distance accurately. The imagination that can see a ship falling through vertical miles of water. The imagination that can understand a railing as both human-made and animal-used. The imagination that can accept that a wreck may be most respectfully known by leaving it where it is. The deepest forms of attention do not always end in possession. The ocean has taken many ships beyond the reach of hands, but not beyond the reach of consequence. What we build can sink. What sinks can persist. What persists can alter habitat. What alters habitat can become part of biological systems, and what becomes part of those systems must be understood with more than nostalgia. The deep sea is not a storage room for human endings. It is an environment receiving them. So the next time a camera beam finds a wreck in black water, the first question is not only what ship is this? It is also where is this ship now, in ecological terms, in chemical terms, in legal terms, in moral terms. What does the sediment show? What animals are using it? What materials are failing? What should be touched and what should be left? The name of the wreck is only the beginning of knowing the place. In the final image, imagine the vehicle holding position beside a section of hull. The lights reveal rivets, corrosion, a pale animal attached to an edge, and particles drifting steadily past. The scene is quiet, but not empty. The wreck is still recognizable, but no longer separate from the world around it. It has crossed into the deep sea, and the deep sea has crossed into it. The surface ship above begins to recover the vehicle. The tether rises. The beam lifts away from the hull. For a moment, the metal fades into darkness by degrees, not all at once. The particles remain visible longest because they are closest to the light. Then, they too are gone. Below, the wreck continues without witness, held by pressure, touched by animals, altered by microbes, and slowly entering the long, patient memory of the seafloor. That memory is not conscious, and it is not merciful, but it is real in the way geology and biology are real. A ship becomes part of the bottom by being altered there. Its plates thin into sediment, its surfaces become colonized, its voids fill, its sharp edges soften. The place where it landed becomes different from the place that existed before. If the wreck is left undisturbed, future observers will not find the same object we filmed. They will find the next version of it. This is why a deep wreck should never be treated as a finished scene. Even the most still image is temporary. A railing that appears firm may fall within decades. A mast may collapse. A sediment bank may rise against the hull. A coral colony may expand, break, or die. A microbial community may change as metal becomes less available or oxygen shifts. The wreck is not a photograph preserved in water. It is a slow event. A slow event can still have urgency. If a site is leaking fuel, it matters now. If a trawl could cross it, it matters now. If coordinates might lead to looting, it matters now. If a baseline survey has not been made, the chance to record current condition may be passing. The deep sea moves slowly, but human decisions around it can arrive suddenly. The most responsible response is neither to romanticize the wreck nor to ignore it. It is to study it as a place where history has entered the deep ocean and become subject to deep ocean rules. It is to recognize that the animals there are not intruders, that corrosion is not failure of memory, and that leaving a wreck alone can sometimes be the most active form of care. Preservation can mean distance. Distance is what these sites teach most clearly. The distance between the deck and the surface. The distance between a survivor's account and a seafloor image. The distance between a human name and an animal's use of the same object. The distance between a ship as designed and a wreck as it exists. Deep water stretches every part of the story until it becomes larger than the sinking itself. And still, the story returns to something small. A camera beam. A rivet. A fish's eye reflecting light. A fragile growth of rust. A sediment ripple against a hull. A manipulator arm held back instead of reaching forward. These details are where respect becomes visible. In the deep sea, restraint is not the absence of action. It is an action chosen carefully. So the wreck remains, not untouched, because the ocean is always touching it. Not forgotten, because people have named it, mapped it, or still search for it. Not alive, because the ship is dead as a machine. Not dead, because life moves across it and through it. It is something in between the categories we brought from the surface. That in-between state is the truth of shipwrecks lost beyond human reach. They are human objects in non-human places. They are endings that became habitats. They are records that decay while they teach. They are reminders that the deep sea is not a blank darkness beneath our history, but a living environment that receives our history on its own terms. The last word belongs not to the ship, and not to us, but to the water continuing around it. Long after the lights have lifted away, that water keeps moving over the wreck, carrying cold, carrying particles, carrying the small lives that make the unreachable ocean less empty than it first appears. Above it, ships will keep crossing the surface, following routes drawn for weather, trade, research, and war. Some will carry instruments that can hear the bottom. Some will pass without knowing what lies below. The wreck will not announce itself. It will not rise into the path of light. It will remain where pressure allows it to remain, changing in small increments, giving shelter where it can, giving evidence when a careful machine returns, and giving the deep sea one more hard shape to use. That is the final scale of these places. Not only the depth in meters, or the date in a record, or the name painted on a hull, but the long conversion from voyage to seafloor, from human intention to ocean material, from loss into a form of presence that no hand can hold. And the water keeps moving,